Thank you, sir, for such a warm and insightful speech. Now, I would like to invite Dr. Sulochana Bhatt ma'am, in charge of PA and PA of Center of Excellence for Research and Clinical Services in Magmena, to give a brief account of today's program. Good morning, everybody. Good morning. Respected Srikanta sir, Professor Swaminathan, Professor Bhatt, Dr. Bhushan, expert speakers, Dr. Praveen Kulkarni, the opening speaker is there with us. Learned gurus and vibrant shishyas of Ayurveda institutions, my colleagues, Center of Excellence, team members from IIT, Prayoga, Samatvam, Gary Bengaluru, friends, ladies and gentlemen who have joined us offline and also online. From 2021 onwards, ever since the Center of Excellence team was awarded to Center Ayurveda Research Institute Bengaluru, we have been organizing training programs every month. We are completing 5 years next month. But it used to be in-house, generally in the institute itself. But this time it is very special because it's happening in IISc Bangalore under the direct supervision of Navakanta Bhatt sir. In fact, it is sponsored by IISc. We are all very thankful to you, sir, for joining. Reason number 2 is it used to be in-house on these days, but this time we have experts who are internationally renowned and inspiring role models. Thank you all for being with us. About the program, it's there in front of you. The sessions that we are going to have, you also have the program. We are going to cover fundamentals of research methodology. I have requested Dr. Praveen Kulkarni to focus on proposal writing because you all are preparing your synopsis. It's yet to be submitted, and then we will have safety issue like pharmacovigilance, patient safety. Then Professor Swaminathan will talk about new paradigms, the new thinking of Ayurveda research. Then we have advanced techniques for drug standardization, characterization of herbal medicines. Then our young scientists from IISc Bangalore, Dr. Madhumati and Dr. Bharati are going to speak about nanotechnology that they have developed at IISc for managing metabolic disorders and also technology related to mass spec. So, Dr. Srikanta sir has kindly consented to wrap up the session at the end of the day. I would like to take this opportunity to inform you all about the schemes of CCRS that are focusing on inculcating research culture in educational academic institutions. You all must be knowing about Spark. How many of you know about Spark? Almost all of you. It's a very good thing. Spark, we give technical guidance and also some monetary support for BA/MA students, undergraduate students who want to work on some project. So that is that 200 students are supported in a year. Then we have PG Star. You all are eligible to apply for PG Star. So PG Star also similar thing for PG students. 100 students are supported each year. Then we have postdoc fellow that you all must know. And very happy to inform the audience that IISc also has got one PDF from CCRS this time under the able guidance of Dr. Then Prayatna is a new initiative. Actually, all these academic initiatives are taken up by our visionary Director General, Dr. They are all research happenings. Prayatna is initiative for fostering scientific writing skills in Ayurveda. They are organizing sessions with events for PG, PhD and postdoc Ayurveda students. On menstrual preparation and the complication. Then for Panchakarma technician course also you must be aware of, but this is not for Ayurveda professionals. This is for somebody else who wants to learn Panchakarma techniques and it's 1 year self-funded course. Then there is certificate course in Panchakarma therapy, advanced Panchakarma therapy. You all are eligible for that. It's 3 months course happening in Charuturthi, Kerala. Then Ayush Diksha Center devoted to HRD for research is being set up at Harry Bhubaneswar. Building is coming up and is going to be a reality soon. So apart from these schemes and structured courses, all the 30 CCRH institutes encourage like-minded individuals and institutes to visit us, have discussion with our scientists, and also we welcome research collaborations and extend access to our facilities at nominal charges. You all are aware of it and many students visit us. And I sincerely hope this turns out to be a very meaningful and memorable to all of us. Thank you, Anena.
Thank you, ma'am, for briefing about the program and the updates. Now we will move on to our technical session. So I request Dr. Vinusri and Dr. Purvi to take over the technical session.
So it is time to begin the session now. Firstly, I'd like to invite Dr. Praveen Kulkarni sir. He is working as Vice Principal and Professor in the Department of Community at JSS Medical College, JSS Academy of Higher Education and Research Mysore. He is a Fellow of Foundation Advancements in International Medical Education and Research. He has received several research grants from Government of India, Indian Council of Medical Research, Bill and Melinda Gates Foundation. He has been recipient of Young Scientist Award from Karnataka Association of Community, Best Receiver Award from Best Reviewer Award from Association for Physicians of Indian Karnataka, and Best Teacher Award from JSS College of Physiotherapy. He is the associate editor of International Journal of Health and Allied Sciences and editorial board member several national and international journals. He was the principal investigator of Covishield, Covovax and booster dose vaccine trial against COVID-19. He has more than 140 publications in various national and international journals. It's a very honor that you are here, sir. We welcome you for your speech and I invite Dr. Navakant sir to felicitate him with the pot.
Very good morning to one and all. I was feeling a bit nervous when I came here because I need to stand before a lot of professionals, and I think I'm the only odd man here from allopathic medicine. So fantastic. I now have company. And I was thinking, okay, fine, Ayurveda is okay, but I better have this from Ayurveda. So, the topic given to me was something related to fundamentals of research methodology. The whole topic is a very broad one. So it is going to be a mammoth task for me to concise the whole thing in a span of say 45 minutes and put in front of you. And Madam has put an additional expectation at morning that they should be able to write their synopsis at the end of attending this particular session. So I try to do my best, and this is the era of information technology, and you can connect with us at any point in time for any further assistance. So, how much ever possible in next 45 minutes, we try to cover, and rest of the things we can take it forward. Initially, there was a concept called feedback. Now there is nothing called feedback. It is feed forward. Okay, what you learn today, you need to take it forward and learn the things well. So, considering that, let me start today's session. And the disclaimer is that whatever affiliations were read for me now, past affiliation. So I'll be joining ICMR as scientist key on 6th of March. I have taken adequate, all appropriate permissions from my previous institution to represent them in this particular forum. So, with that disclaimer, I will go to my session on fundamentals of research. Fine. So, when people start asking, the moment you enter into post graduation, everyone starts, you need to do research. So, some people start thinking, oh, something, an additional burden is coming on me. Don't take it as a burden. As I was making a mention, if you ask right questions, you are going to get the right answer. Develop the ask of asking the right question, then you are going to be a good researcher. Okay. So now the change is changing. If you are good in research, you are 500 meters, behind the next person in 2 kilometer race. If you really want to compete in this world, you need to be strong in your research. Do not hate research. If you hate research, hate you further. Try to love it. Try to embrace it so that it will be easy for you to take the things forward. Why on this earth we need to do research? The first thing is it is a matter of discovery. Sir was making a mention, it's going to be the era of Ayurveda professionals coming out. Lot of new discoveries of medicine, lot of new innovations. So research need to be done for discovery. Second reason why we do research is develop critical attitude. Research will help you asking questions. Research is to generate knowledge. Research is to sharpen knowledge. When you want to generate knowledge or sharpen knowledge, you will not accept anything that comes on the head. You will be asking why. So what? One of my mentor in my Gamer fellowship, she used to always ask the question, so what? I want to do this education innovation. I want to train medical students on communication skills. She used to ask, so what? So what? When you ask so what, it will help you to think a bit extra. We used to answer. It will help them to sharpen their clinical practice. So what? It will help in attracting more number of patients. So what? Healthcare is going to improve. So what? Health of the country is going to improve. So what? When you ask subject. My wife did her PG dissertation on the Rasa Dushna Lakshana PCOS patients attending Mysore. And the point is, once you start working on that particular area, you become an expert in that. People start asking you whenever there is an opportunity in the institution to whom to contact, then your name will come. It is a matter of prestige. You will be recognized. It is a professional identity formation. You will develop in-depth understanding about a particular subject. And it is recognition. When you do a particular research, when you do a particular grant, now madam is being recognized for her work in diabetes. There will be some people who will be working in yoga and its impact. So they are recognized for their work. When the government of India starts thinking, we need to create an expert panel related to diabetes, whose name comes first? Madam's name. It is a matter of recognition. You will be recognized by your work. And ultimately, when we are all in the academic fora, it is publication. If you do not publish, you will perish. It's a very commonly used, publish or perish. Now it is publish and flourish. You need to publish. Unless your work gets recognized from outside outside world, you are not going to be called an expert. So I was attending some of the Ayurveda and indigenous medicine related seminars. One of the common reason Ayurveda and indigenous system of medicine, please correct me all Salvers sitting here, did not get the same sort of recognition as that of allopathic medicine was because lack of publication. Lack of publicizing our discoveries. There could be many reasons. We need to publish, we need to disseminate the information. Once you disseminate the information, people will recognize it. And it is going to be a matter of prestige. In a very simple term, why you need to publish is you need to get promotion in your work, right? Unless you publish, you will not be promoted. It is as simple as that. But publication will remain for lifetime, beyond your life. If people want to recognize you even after you are dead, you need to do two things. One, produce children, produce publications. So both the things will keep you alive. Your name, fame will be alive. And it helps in acquiring additional skills, knowledge, and also leads to higher degree. As all of you have started your MD Ayurveda journey now, you need to do your dissertation. Only if you do, you will be getting your degree. Otherwise, you will not be able to get the degree. Okay, and it is going to increase the opportunities for further funding. So when you write a research proposal for funding to any funding agency, first thing they will check whether you have expertise in that particular area. How expertise is checked? It is based on the number of publications you have, the number of research projects do you have. It is like a group of people sitting and they'll be evaluating your projects. And the moment they look at the principal investigator's name, they will check how many publications are there in this area for that principal investigator. If you have good number of publications, previous research experience, your chance of getting the grant is going to be more compared to the rest. So problem is why we do not do research. The first thing is fear of attending. It is not my cup of tea. Why should I do the research? I need to do clinical practice. I go to patients, investigations, give them some therapy. They'll be all right. My pocket is full. Why should I do the research? And if it gets rejected, if people start questioning my competency, the fear, insecurity. Second reason is fear of criticism. The moment we submit a paper for publication, we should be ready for criticism. If you are not open to the criticism, you are not going to be a good researcher. Criticism could be of any kind. When I submitted my first paper, the reviewer wrote to me, you join kindergarten school because your English is very bad. If I would have taken it very seriously, I cannot join kindergarten school, that's a different matter. But the problem is, I would have been demotivated for doing publications. They read 140, currently I have 186 publications in national and international journals. Point is, if you get rejected with the criticism, then you are nowhere. So be open for criticism. If you have these tendencies of getting rejected with criticism, get rid of them. Lack of time. Who has time on this earth? You ask my UKG daughter. She says no time. You ask my co-chancellor of a university who handles several meetings a day, and you just write an email, sir, I want 5 minutes of your time. He says, please come. Time is a relative concept. You want to give time, you will give. For what? If you give ample of time on this earth, why not for research? No time to write publication, no time to write research. Lack of resources, it is again another problem. So it is not at our level, the institutions have to take care of it. And lack of expertise, such kind of workshops will help in developing the expertise. And sometimes there will not be very high environment that could be. What is this research? There are many definitions for research, but something that I want to highlight is doing something systematically is research. How many of you have lost your keys anytime in your life? Please raise your hands. And what you do after you lose your key? You search for it, and if you do not get it, you will go for a key vendor who will make a duplicate key. Don't you think that person who does duplicate key does a research? He does research, right? He takes a bunch of key and he will match to the lock, and then chisels it, does permutation, combination multiple times, and finally he succeeds to open the key. So it is a research. But is he doing systematically? No. He does it. If you do the same systematic process, it is called research. Research is doing something in a systematic manner, following all the steps, protocols, standard operating procedures. If you do that, then it is considered to be the research. So there are different types of research. I will not go much into the details of it because most of you will be doing some sort of clinical research and some sort of biological research or research at related to research inside, something related to the biochemical parameters, pathological parameters. In large, in my experience with Ayurveda students, they do a lot of diagnostic research, wherein one of the diagnostic modalities are related to the clinical features and related to the interventions. Okay. So by giving one Ayurvedic formulation, how the disease progress is compared to rest. So these are few type of research that we do. ICMR has come out with this 4D framework for getting better funding opportunities. So maybe the council can also use this as a framework when you are trying to give funds to the graduate students for their dissertation work. 4D framework. Number one, your research has to be at the level of discovery of a new medicine, new molecule. Second, it is related to the developmental type of a research where you will be developing a particular intervention, particular therapy. Third is related to delivery. It is called implementation research, where a program is running, you will be checking how it can be implemented. And fourth is related to descriptive. To what extent a particular intervention is making an impact. These are four type of research projects or research ideas the government of India will welcome for doing the research. What are steps in conducting research? So first and most important thing, before going to the steps, I just want to ask you, how many of you cook well? Very good. So let me start with you, ma'am. So today we have to prepare one dish for afternoon. Okay. So what do you want to prepare? You need to cook. Yes.
Sabzi and chapati.
One dish. Khichdi. So in menu there can be any number of things. What we want to cook, that is selection of, you need to select what research you want to do. Khichdi. Is Sulochana madam is the only person on this earth who thought of cooking khichdi. Yes or no? No. There may be n number of people who have done khichdi, right? So you need to search the literature who are all the people who cooked khichdi and download their recipes. I cannot explain research more simple than this. You have now downloaded 15 recipes for cooking khichdi. Can you use all 15 to cook khichdi? No. So you need to evaluate among them which is the most suitable thing for you to cook khichdi. In one recipe, something may be good, in the other something may not be good. You will be finding out which is good with all that you do khichdi out of khichdi, recipes, and then identify one recipe to cook. That is your research question. I want to cook khichdi using these ingredients. That is your objective or aim. I'm going to cook khichdi. And then there may be many procedures to cook khichdi. You'll select one procedure. What should be added first? After that, what next to be added? So you will design. So you will have actualization. This is how I want to cook khichdi. That is called identifying the design, study design. And then you will identify what all ingredients required. So that's called study subjects. Who all to be added to my khichdi. That is called study subjects. And then all of them one after the other and cook khichdi. Okay. What is called collection of data. And after that, you will be tasting one spoon of that khichdi and checking whether it is palatable or not. It is good or not. After that, you will be adding some more additional things so that you make it more palatable. It is called data analysis and interpretation. And then you will serve it to people. They will eat it and they will express whether it was good or bad. Somewhat good, manageable, eatable, can be tried next time. You will get these kind of responses, right? It is presentation of your data. And then comes discussion. They prepared khichdi like this. I prepared like this. What is good in my recipe and what is good in their recipe? How can I make it well? It is called discussion. Right? Discussion is comparing your khichdi with the rest of the khichdis on this earth. Thanks for giving that khichdi. Sometimes when I ask, I get very wild. I want to cook chicken biryani. The problem is I don't know how to cook it. Khichdi is more universal kind of recipe. Now compare your product with the rest of the products is called discussion. And after that, you will write a report. Next time when I want to cook khichdi, I want to cook it like this. And you will keep it as a saved report in your kitchen. Will madam stop at that point? What will she do? She will make a YouTube video on how to cook khichdi and she will disseminate that is published. These are the steps in conducting research. I have not said I cannot explain anything easier than this in how to cook, how to write. The whole business starts at if you are a good cook, you are a good researcher. Because you have critical thinking attitude, you have flexibility, you have tolerance for critique, right? And you have ability to showcase yourself. You have ability to disseminate your knowledge and skills. And more than that, you are more skillful and patient. Not that patient. I have a lot of patience. Okay? So this is the art of doing research. The first thing is how to get a good research topic. You may get good research topic by going through the reputed journals. When students come to us, we'll ask them go to 3-4 journals in our subject area and look at the recent articles and read them and get 5-6 topics of your interest and which are feasible at our setting. Bring them. We will finalize one among them. And second is you need to attend conferences, and when you go to conferences, please attend the conferences. It is a disaster. Students make a list of calendar conferences, and when they go there, we need to pharmacovigilance. You were talking, no? Student vigilance. Whether they are really there in the conference. You need to go there and listen to the deliberations, and at the end of conference, they give you a souvenir. Abstract book or a proceeding, you need to go through that. That will give you an idea about how to select the topics. I'm keeping it a bit light, but don't consider it as a stand-up comedy session. So, point is, if I keep telling, talking about it, I can talk whole day. But the problem is, how much will enter inside is an issue. So, I'm feeling you are overhead tank. Okay, so keep it open. Open from top, not from. Identify what are the thrust areas of various funding agencies. It could be ICMR, DBT, DST, or any funding agency related to Ayurveda. What are their thrust areas? Identify, and based on those 4 Ds I told, you need to design, you need to identify the topics. And textbooks will also help you in identifying topics when you really read them carefully. You will identify some knowledge gaps in the textbook. So it will help you in developing the ideas. And you can go for WHO, UNICEF reports. They will also help you in identifying the research areas, because they will say these are the areas where we need to do additional focus on. Once you do this exercise and select the topic, ensure that it follows these 5 criteria. Final. The study should be feasible. You should be able to do it. And it should be interesting. It should be interesting to you as well as to the community. One of the students came and told, sir, I want to do a research on depression associated with early graying of hair. Okay. So I found it very interesting. I told, what made you choose this topic? He told, no, sir, I have developed early graying of hair. Because of that, I developed depression. I started thinking myself, I also got early graying. Now, in fact, hair microscopically fine. So, a person develops early graying of hair. He will look into the mirror, identify hair, and plucks it off. 5-10 minutes, he will feel low. And after that, the life goes on. Who will go into depression and suicidal tendency that I have developed graying of hair? So this topic will be interesting to him. But is it of any translational potential? No. The topic has to be interesting and it should be relevant to the current context. Student came and wanted to study on multiple myeloma. Multiple myeloma is a bone-related disease and it has got something to do with the hematopoietic system. The person came and told, I want to do multiple myeloma. So it is a 6-month MBBS UG project. And I told, you just go to the hospital and find out how many patients of multiple myeloma come to JSS hospital. And based on that, we can design. He told, sir, in last 6 months, 2 patients of multiple myeloma came. Why on this earth you want to do this? My grandmother died of multiple myeloma. Problem is, it is a problem. But can we do? Is it feasible? One student came and told if she wants to do it. She had actually proposed a study. It was submitted for the synopsis. It was on deep vein thrombosis among patients undergoing major surgery. Sample size selected was 100. Study was done. And at the end, she collected 99 samples. Not a single patient had got deep vein thrombosis. She came and asked, no, 99 are over, sir. One is remaining. It is a matter of chance. If I don't get that one also, what will I do? Then I told, who gave you the sample size of 100? No, sir, by arbitrarily select. I told, do some literature search. And in literature search, it was clearly visible that for getting one deep vein thrombosis, you need to observe at least 600 major surgeries. Not feasible. The topic you choose should be feasible, interesting, novel, new. Now it is something new. There should be something new in that. Otherwise, why you want to do the same thing again and again, reinventing the same field? It should be ethical. Again, ethical components will be covered in next session, and it should be relevant to the current context. Go with a funnel approach. Start with broad and then narrow down. Let us take this example. Very vague thoughts. What kind of vague thoughts? Vague thoughts will come when you are sitting quiet or you are traveling in the bus. Nowadays, traveling in bus has become a horrific business. Initially, when we used to travel in bus, we used to get a lot of free time. Now, when you travel in bus, you need to look only at the fighting that goes on. So, point is, when you are calm, you will have some vague thoughts. Is there any way I can prevent this due to lifestyle disease? It's a very vague thought. Next comes, you identify a broad area. There may be large number of lifestyle diseases. Diabetes is a lifestyle disease. Hypertension is a lifestyle disease. Stroke is a lifestyle disease. Cancer is a lifestyle disease. So, which among these lifestyle diseases I need to take? Then take one lifestyle disease, say diabetes. And in diabetes also there can be multiple domains. Do you want to study epidemiology of diabetes, prevention of diabetes, treatment for diabetes, where you want to go? Among them, identify one domain, that is treatment. I want to work on treatment related to diabetes. Whether I need to try on a new drug or a combination of drug or a different dosage formulation. And among them, you prune down to one particular drug. Whether this drug is effective against this is how you prune down your topic for research. Another example, COVID-19. What are the predictors of mortality in COVID-19? COVID-19 you can study a number of things. You can study epidemiology, risk factors, treatment modalities, diagnostic modalities. What are the preventive modalities? So among them you identify what are the predictors of among them, what are the roles of inflammatory markers in prediction of mortality? Now, that is your research topic. What is the predictive ability of inflammatory markers? Then do a thorough literature search. If you do good literature search, it will solve half of your problem. These are a number of lists I have given to you for doing good literature search. We do a lot of what you call alasya in literature. Who will search and who will read if you do not, there is a very important saying. I think if any one of you have a habit of reading our textbook, someone who doesn't read the history will fail in future. You need to read it. If you do a proper review of literature, you will identify what has been done by others, what has not been done by them, and that itself gives you a topic for your research. Students do not do a review of literature, and the problem is the example I gave you. You need to do at least 600 surgeries to get one DVT patient. If the review of literature is not done properly, it will lead to everything is at your tips. You ask sir and madam. So at my time also things were a bit easier. At their time, for getting one dissertation, they need to go to Bangalore University, Mysore University, go to that college, get a number of books and dust. Clean them, identify, take a Xerox, and Xerox machines are also not available. My teachers used to tell me Xerox machines were not available to write and bring. Now everything is at your, it's not even at your tip of finger, tip of your tongue. You may not even type to chat GPT. Tell it. It will give you everything. Use it judiciously. Okay. Do not use it for manipulation. Use it judiciously. I have listed a number of sources for review of literature. Something I want to get your attention on. Grey literature is something not published. For example, you go to your libraries, your seniors' dissertations will be there. So they are so lazy that they do not want to publish them. If it is published, it will be there in the public domain. If they have not published it, so it will be available in the rack. It is called as a grey literature. One of your teachers have done some extensive research and written it as a report, but unfortunately they were not able to publish it. It is called as a grey literature. And after that, write this literature matrix. The moment you read a paper, make this as a habit. Please write it down. When you are doing review of literature, follow this simple table. The first column is what is that paper? Title, citation of that paper, or how to cite this paper will be there in that. What is the research question in that particular paper? What research question they have tried to explore? Number two, what is the study sample? Who are the study population among whom the study has been done? What sampling technique they have used? What is the design and what is the method they have followed? Write it down. Teacher who used to write, he is still there in KIMS. He writes, he has a notebook, register. He used to write everything. He was not very particular about typing. He used to write everything. The moment you write, you will have better retention. But if it is okay, fine, don't write. At least type it. Now, what is the result of that particular study? Important results. And then what are the comments? Comment could be sample size is not calculated properly. The study is done only in urban population, not in rural population. Study is done only in rural, not urban. Though the tribal is approachable, they were not able to do it. The sample size is very less. Sampling technique is not correct. So these are all the loopholes that will help you in designing your study. So after that, come out with this literature framework. This includes what are the issues under consideration. So in that study, we found that the sample size is very low, and the study was done only in the urban communities. And with that, what they have identified, what have not identified, what is lacking in those papers, and then what can be done in your study to get rid of those limitations, and how you can do it, and finally how will it be different. Put these things in a frame. I don't have much time, so I would have explained everything quite in detail, but at least take this picture and to see it, it will be able to, you'll be able to understand. Issue under consideration is prevalence of diabetes. What is known, prevalence is known for rural, urban area. What is not known, it is not known for tribal area. Okay, how can you do it? Approach tribal areas, and how it can be done. What strategies you want to follow? Put it at the end. So it will give you a nice literature, and then write a proper research questions. I was making a very apt mention on how research question has to be. It has to be very clear. We use something called as PICO framework. That is population or a problem, intervention, comparison, and outcome. So PICO is the format that is usually used. Sometimes all PICO components may not be available in all the research studies, but at least try to have either PCO could be there or only CO could be there. You need to just find out what best can be done. Write objectives correctly. The moment I review the synopsis, the first thing I will see is whether the objectives are correctly written or not. Students will vaguely write the objectives to observe, to study, to know, to understand, to listen. How can you measure listen? All of you are listening to me, right? There are people who are sitting down, there are people who are sitting in front, there are people who are sitting, and everyone have got different capability to listen. How do we measure it? To observe. How are you going to observe it? To know. Each person's knowing capabilities are different. Instead, if you mention to estimate, to evaluate, to compare, to describe, to assess, all these are measurable terms. Objectives are how you are going to reach your aim. Okay, so you need to be clear about your objectives, and the objectives have to be smart. They should be specific. They should be measurable. They should be achievable. They should be relevant, and they should be time-bound. If you do not have your objectives in this framework, smart objective, the whole study is going to collapse. Students come and ask us, sir, I wrote this objective and I found that I was not able to achieve it. What do I do? Then the first question I'll ask, why did you not introspect well before writing that particular objective? You think it is not measurable. Sometimes it will be very unfortunate. One of the students anticipated that there will be a third wave of COVID, fourth wave rather, and fourth wave is going to affect children only. And he wrote a research proposal, synopsis. And fortunately for the world and unfortunately for him, wave did not come, and that wave did not affect children even if it would have come. So we had to change the topic. Okay. So the point is, anticipating too much is also not correct. So consider what is relevant to the current context and try to put it properly. Next, coming to this is the difference between aim and objective. Aim is where I want to reach. Objectives are how am I going to reach there. You just look at the aim there. To study the safety and immunogenicity of Rabipur and Virora. These are two anti-rabies vaccines for the post-exposure prophylaxis among animal bite victims. In aim, we are mentioning I want to assess safety and immunogenicity, but I am not mentioning how am I going to measure safety and how am I going to measure the immunogenicity. So those things are put in the object. How we are going to measure the safety by looking at adversity. How you are going to look at immunogenicity by measuring antibody status. Okay, so this is the difference between aim and objective. As you're all going to write your synopsis, my advice to you is don't write too many objectives. Enough. That much you achieve methodically, and ethically is fine. I've seen students writing list of objectives, 8, 9, 10. And when writing dissertation, delete all of them and retain only 3. What is the fun in doing that? When you're writing objectives, most of the teachers are agreeing with me because I have been in academics since last 14 years. Now I am moving away from it. I enjoyed every bit of my presence in academics. Point is the moment the student brings synopsis, we will understand whether the student has given proper time for writing it or not. The first look itself is going to give what we see objective, whether objectives are properly framed or not. Keep 2 or 3 objectives and satisfy them, and do everything to measure those objectives. That is more than enough. Now let me come to the last but one part of my presentation: identifying the study design. Make 2 decisions. The first decision, whether you just want to observe the event, they're called as you need to go for observational studies, or you want to intervene, they're called as interventional studies. I'm just observing all of you sitting here, and all of you are listening to me. I'm observing. There may be one or the other person who is creating problems somewhere, but fortunately, first time I'm seeing, I need to compliment the organizers. So fantastic set of audience. Nobody is doing anything, no extracurricular activities have been done. When you find somebody doing an extracurricular activity and you intervene there, then it is called as interventional study. I always give this example because I find 1 or 2 in that, in the group, but here I'm not finding anyone. Very good, fantastic. Give an applause. Retain the same energy till the last session. Observational or intervention. And in observational also, whether you want to just describe or you want to analyze. Describe. I will say my daughter is the brightest one. She is very smart. She is very polite, and she studies very well in the class, and she does her homework very well. I am going to contribute a scholarly child to the world. I am describing it. People will not agree. You say your child is the brightest compared to whom? Then comes analytic. Are you getting me? Descriptive means you are describing a particular disease. You are describing a particular event. When you do it, it is called descriptive. And when you compare it with the other one, it is called as analytic. In descriptive, if you want to just describe, check whether you want to describe only one case. It is called case study. You want to describe series of cases of a particular disease called case series, but something should be common across all of them. The disease should be same, an outcome should be same, or a symptom should be same. Something should be common. If India and Australia play one match, it is called case report. If they play a series of matches, it is called case series. What is common in the series? India and Australia. Understood? Okay. Now, if you want to take a group of individuals and study them at one point in time, it is called as cross-sectional study. IISc is sponsoring this workshop. IISc can do one thing. They may check how the students are attentive in this particular workshop. They can do 2 things for that. Number 1, they can come randomly and take a photograph and analyze that photograph. Among 60 participants, 30 were listening, 10 were acting like they were listening, 5 were taking notes, Two were looking at the mobile phone. One was sleeping, other was about to sleep, and one was yawning. So what is the effectiveness of this workshop? 50%. Do you think it is the correct way of assessing it? Things were done at one point in time. It's cross-sectional. What they would have done otherwise, they would have fixed the camera and observed it over a period of time. Follow. When you do that, it is called longitudinal study. When it is done at only one point in time, it is called cross-sectional. In analytical also, if you start from effect to cause, go back in time and find out whether there is an association between effect and cause. It is called case control studies. You take a group of individuals who are having the disease, you call them as cases. A group of individuals who do not have the disease are called as controls. Cases are having the disease, controls are not having the disease. Go back in time and find out among cases how many had exposure, among controls how many had exposure. All these things you have studied in your Swastha Vrata, I need not tell anything again, but just rebrushing your mind. It is called retrospective study. And the prospective is, instead of starting from the disease, you start from exposure. Start from smoking. Take a group of individuals who have habit of smoking, a group of individuals who do not have the habit of smoking, follow them up over a period of time, find out among smokers how many develop lung cancer, among non-smokers how many develop lung cancer. As it is prospective in nature, we call it as prospective study, or it can also be called as a cohort study. Then comes interventional studies. There are two types. One are randomized controlled trials and non-randomized controlled trials. Randomized controlled trials are the one where in interventional studies you are doing an intervention. In intervention, when you are allocating groups for intervention, one group will receive intervention, other group will not receive intervention. If you allocate individuals who receive intervention, who do not receive intervention randomly, it is called as randomized controlled trial. And if you do not have that provision, it is called as non-randomized. Let us take this example. I told during my introduction, I was a part of Covishield trial. I was the investigator principal in it. Can I take another 10 minutes? Yeah. I'll finish exactly at 10:30. When the participant comes to the trial, we do consenting. And then we will tell him, so you have come to the trial for participation. You can be in two groups. One among the two groups, either you will be receiving Covishield vaccine or you may receive a placebo. Placebo is something which looks like drug, but it is not a drug. There is 25% chance that you may receive placebo, 75% chance that you may receive. I don't know what you will receive. And you will also not know what you will be receiving. Once you collect all the data from the study participant, you will feed it in the computer software. It will randomly allocate a kit, and you take a medicine from that kit and you will administer to the participant. Neither you nor the study participant, nor anybody in the team has got any control on what type of medication who has received. This is called as randomization. Okay. So this kind of randomization may not be possible in all the situations. Because your test drug is available as a tonic, as a syrup, and control is available as a tablet. That time blinding and randomization becomes impossible. And surgical interventions, when you are planning to do the surgery, you decide on the table what type of intervention the participant has to receive. At that point in time, the randomization becomes a problem. At that time, you go for a non-randomized. Okay. So to call a particular study as a randomized controlled trial, you should do the randomization. I think one of the students from Ayurveda college, I was a study participant in that. She collected all baseline parameters of us, and then BMI, blood sugar, HbA1c levels, cholesterol, all those things. and then she gave us a medication. We had to take that medication empty stomach for 30 days. And after that, she reassessed all the parameters among them. I asked her how you are planning to do it. She told I'm going to take only one group of subjects. I do pre and post. So there is no question of randomization. So you call it as non-randomized trial. On the other hand, if she would have taken that particular medication and a placebo, one group of subjects she would have given that medication, other group of subjects she would have given a placebo, and assessed both the parameters, all these parameters pre and post in both the groups, it becomes a randomized control trial. And provided she allocates the subjects random. Okay. So this is what we call as randomized and non-randomized. And then you need to write methodology. Please remember these things you need to mention in your synopsis. What is the place of your study? Where you want to do this, your research? Whether you will be doing it in the hospital or in the community. If it is your hospital only, or you are aligning with any other hospital. One of my MPH student, he did a study on the cost effectiveness of Ayurveda medications in osteoarthritis. Okay. And the treatment Ayurveda and allopathic. So I do these kind of adventures. 3-4 of my students have done these kind of studies. One has done on rheumatoid arthritis, one has done on osteoarthritis, and one student has done on cardiovascular diseases, and one more has done on stroke. Okay, so they compare the cost and outcome. Okay, so what he has done is he did study in both JSS Ayurveda Medical College and Government Ayurveda Medical College. So student was from Government Ayurveda Medical College. He came for doing MPH under me. So I made best use of it, and we did the study and we published it jointly. Okay. So what is the place of your study? You need to clearly mention it. What is the duration of study? Whether it is going to be about 6 months, 1 year, 1.5 years, you need to mention it clearly. And when you want to do that study, that period also you need to mention. Who are all going to be your study subjects? Adults, children. If it is adults, whether any special group you are taking, like adult diabetics, adults with osteoarthritis, rheumatoid arthritis, something like that. You need to find out, you need to fix the period. For example, one of the students wanted to study on the quality of life among diabetic patients. If a person's quality of life to be affected, he need to be suffering from diabetes for a certain period of time. Especially diabetes is detected today, I will assess quality of life means what? I should be having diabetes for some time. Then you need to fix a time period. So person should have diabetes for these many years. What type of diabetes? Type 1, type 2, all these things to be mentioned. What is your sampling technique? Whether you'll be doing a probability sampling or a non-probability sampling, I think you will have to read all these things because of time I will not be able to do. Inclusion criteria and what is your exclusion criteria. What criteria make a person to be included in the study, what to be excluded in the study. One simple tip I want to give you, do not keep inclusion and exclusion criteria mutually exclusive. I will be including 18 to 65-year-old population in my study. Inclusion criteria. Exclusion criteria, people less than 18 years, more than 65 years will be excluded. Just to fill the place, the students write it. My own students write it and bring. When I ask why did you write it, so something has to be written there. There is a heading. Okay. So if you keep empty, people will start questioning your competence. Okay. So please do not keep it mutually exclusive. Okay. So if you want to include, if the study is on males, it means that the study is on males. You do not mention I want to exclude females. There was a headache Bangalore when I was doing a PG. There was a board. Hendu Makkala Prasuti Kendra. So, this is So you don't get Gandu Mankara. It is implied. It is implied. You need to keep it very simple. And person who is reading it, he has done MD, he might have done PhD. So much of effort would have been his hair would have laid or washed his hairs looking only at students like you. Okay, give respect to them. And you need to write method of data collection. How you are going to collect the data, whether you are using any sort of a questionnaire, whether you are using any type of scales, or whether you are using checklist for data collection, or whether the instrument that you are using is validated or not. These are the questions that you need to check. And if you are using the scales, please remember at the time of conceptualization of the study itself, check whether there is an analysis guide for that or not. One of my junior, she did a study on perception of illness among diabetic patients. She downloaded a questionnaire and she started using it. She collected data from 1,000 diabetic patients in Parvatipura. Next to KIMS, there is an area called Parvatipura. So she collected data from there and data collection was done and she was about to do the analysis. And when she started analyzing it, there was a surprise that there were no cutoff to call perception of illness was okay or poor. There was no cutoff. And there was no analysis guide for it. When we started exploring that scale, we got to know that this scale is applicable only when you do study in two groups. One group having diabetes, other group not having diabetes. Now, she was at the back end of her dissertation submission and 1,000 diabetics she has already collected. She cannot analyze the data unless she collects 1,000 non-diabetic subjects using the same scale. Please remember, when you are using the scale, understand whether there is a proper analysis toolkit is available or not. And whether the questionnaire is self-administered or it is to be, you are going to interview the study participants. Once a person came and she just threw a questionnaire on my table and went off. I was sitting in my chamber, she just came, threw a questionnaire on my table, and went off. She did not even bother to look at me, talk to me, take my consent. She just ran away. I usually do not chase these kind of people. So I just kept quiet, kept the questionnaire on the corner of my table, and I was just, I did not bother about it. After 15 days, she came. I was sitting on the chair, same table. She came, silently collected the questionnaire and started going out. I could not control. I chased her. God, come. What is your problem? You came to my chamber, through questionnaire, and you are, without even asking whether you have filled it or not, you are just taking it and going. What is your problem? Then she said, I wanted to check whether you will respond to it or not. She wanted to check what is non-response rate. Who will respond? Now people go beg them to respond, they will not respond. Once you enter into this field, you will realize the nitty-gritties. She came, you went, you cannot walk into this campus anytime in your life. As long as I am there in chest. So I will ensure that you will not walk in. Problem is whether you will self-administer the questionnaire, you will ask on yourself, or you will just give it to the people and make them respond. You need to write in your synopsis correctly. If you want to use something using the case record, you check whether case records are completed or not. Case records are filled by whom? PGs. They might have not filled it correctly, fully. What will happen to the missing record? Who will collect it? That need to be mentioned. Who will collect the information? Whether you will collect, your juniors will collect, whether your interns will collect, that should be mentioned. If your interns are collecting the data, please remember that you need to adequately train them. Okay? And utilize them. So there is nothing wrong in not in using them. Utilize them judiciously, train them and use. Tell them what to mention where. There was a question, marital status. Please excuse me. There's a question on marital status. Married, unmarried, widow, widower were the responses I was expecting. Marital status, she had written satisfactory. Problem is, it was not trained properly. It is not her problem. It is my problem. I have trained her problem. So, when you want to write, so, I'm very sorry, I'm keeping it very light. So, other than all feel bored. What is the end message? Kitchen. So, how the bias is going to be minimized? How you are going to minimize the bias? Same problem. One student wanted to study on suicidal tendencies. His so total sample size was 180. He collected 160. No suicidal tendency. Another 20. If he doesn't get at least 5 suicidal tendencies, his study is going to be flopped. He went and started asking the person, "Did you ever think of it?" He said no. Think. Whether you really committed suicide. No, I've never. When there was a breakup, he never attempted it. When you saw others breaking up, I never saw anybody do it. At least in your dreams. Then this person decided until I will not do it. Yes. I got one suicidal dream. How you asking correct questions is something that makes sense. Right? What is your diagnostic criteria? Standard diagnostic criteria has to be mentioned. And then who will, if there is a sample, blood sample collection, how much sample will be collected, who will collect the sample, and how it will be processed, and description of laboratory procedures. Sometimes we just copy and paste, please avoid doing it. And how are the subjects allocated into study and control groups, whether it is a random allocation or a non-random allocation. If you are trying to do a clinical trial with new drug, always approval from DCGI is mandatory. And then what will be the type of intervention? People think intervention is only medications. Intervention could be educational intervention also. Now what we are doing is an intervention. Okay, so there are 150 postgraduate students who have attended the research methodology workshop. So they are all our intervention group. There may be another 1,500 who have not attended. So non-intervention. So intervention could be a training intervention, educational intervention, or it could be a lifestyle intervention or a preventive intervention. Okay, then you go for a statistical analysis. At synopsis level, you need to mention you are going to tabulate your data and you are going to use relevant graphs, and you need to mention what descriptive statistical measures you are going to use, like percentage, mean, standard deviation, like measures of central tendency and dispersion. And then you need to mention what inferential statistical tests, like test of significance, you are going to use. Better at this point in time, it becomes very heavy. Try to consult your biostatistician in the department. So they'll be helping you in. So a common paragraph that is written is the data collected will be entered in Microsoft Excel and it will be analyzed using the software. Whichever software you have, you may be having SPSS, Stata, R, whatever. The descriptive statistical measures like mean, median, percentage, standard deviation, interquartile range will be applied, and relevant inferential statistical test will be applied. The data will be interpreted statistically significant at the p value of less than 0.05. And the data will be represented as table and graphs as relevant. So in one breath, you can mention all these things and finish yours now. But when it comes to dissertation, you need to be really careful. And then coming to the data analysis and interpretation, so you need to, it is all playing with numbers. Okay, your statisticians will help you. And my sincere advice to you, I think I'm finishing it another 1 or 2 minutes. My sincere advice to you is don't go to p-value. People come crying. I've done so much of effort, sir. P-value is not coming statistically significant. My guide is scolding. Problem is not with the student. Problem is with the guide. You should not be obsessed with p-value. P-value is a number. I will tell you an example. 300 study, 300 control participants, an antihypertensive drug was given, there was reduction in blood pressure in study group by 20 millimeter of mercury. It means that it is making a significant change. And with 300 studies, 300 control, we were not able to get the statistical significance. On the other hand, 1000 study subjects, 1000 controls, the reduction in blood pressure was only 0.5 millimeter of mercury. We got statistical significance. So now you think whether clinical significance is more important or statistical significance is more important. Strike a balance. Based on that, you need to design yourself. Correct presentation and interpretation of data is very important. Unless you publish your research, it is of no use. Publish it. Publish it in good journal. Publish it in journal with good impact factor. Publish it in peer-reviewed journal. Write the manuscript, show it to multiple people, and get the corrections done, and submit it. Respond to the reviewers patiently. I told how reviewers will respond. A comment. My comment was disastrous. But at that point in time, I cannot send an elaborate reply to him that I have studied in St. Joseph English Medium School with aggregate of 95% with distinction, 6th rank to the state in 10th standard. I would have sent a reply of that. I have not done anything of that. So I'm telling you, the point is, write an elaborate reply, but that time patience is important. Fine. It is his perspective. You need to respond patiently to it. Don't scold the reviewers. Okay, so reviewers are doing their work in kind. Nobody is paying for reviewers. Remember it. If I review a paper, I'll spend my personal time and do it. Nobody is going to pay you 5,000 rupees per review. It is not. Remember it, and it is a unpaid, thankless job. So self-criticism, you need to criticize, you need to put yourself in the critical pathway and then do it. The final word is, there is no way to get experience than experiencing it. You go through the experience. Unless you do the research, you will not experience it. And unless you experience it, you cannot do the research. You will understand the depth of water only after entering into the water. Don't stand at the bank and check the depth of water by throwing other person inside. And checking to what extent he is going to, get sinked into something into the water. Point is, enter into the water. It is the right time you need to enter into the water. And what criticism indigenous systems of medicine have faced over a period of time: lack of dissemination, lack of scientific rigor, lack of evidence. You need to disprove it. How evidence-based medicine has taken a shape in allopathic medicine, similar evidence-based medicine should take a major presence in Ayurvedic medicine also. The path is very, very long, but you have started it. And I wish all of you to have a significant path in your research and experience it. And once you experience it, share with others so that others will also experience it. And unless you share, you are not caring. So sharing is a way of caring. So share, care, do research, do ethical research, do moral research. I would like to thank Shubhashri ma'am. Thanks, Sulochana madam. Thank you very much, ma'am, for having me over here. I've never thought I'd enter into IISc campus. So thanks for making me enter into this campus. The time permits.
Namaste. Only one point. I wish I had him as my guide.
Thank you very much.
Any questions?
Sorry for taking a bit extra.
Thank you so much, sir, for the presentation. It is indeed a very good base for this orientation program. I would like to thank him by giving him a token of love by Dr. S.K. Giris.
ಅದ್ರ ಎಂತ ಬರ್ಬೇಕು
Moving on to the next section from Dr. Pratibha Nade. She is the founder and director, Akshay Therapy Healthcare Solutions Private Limited, Bengaluru, former head of Department Pharmacology, ADR Monitoring Center, Pharmacovigilance Program of India, Meteorovigilance Program of India, Vaidehi Institute of Medical Sciences, and Research Center and Dayanand Sagar Institute, Karnataka. Currently, Chairman, Institutional Ethical Committee, Rainbow Hospital, Bengaluru, and Advisory Board Member, Clean Tech Research Private Limited. She has been recipient of Lifetime Achievement Award conferred by the Medical Pharmacologist Society for Understanding Contributions to Pharmacology. She has received several research grants, DD Prayas Grant, DSG, Government of India, RGHS Research Grant, and Biotechnology Ignition Grant. Core team member in developing the polyherbal anti-allergic formulation ALAR7 natural remedies. Published 45 peer-reviewed research articles and author of 2 books chapters. Conducted 65 training programs in research methodology, pharmacovigilance, GCP, and medical educational technology. She has delivered over 50 plus invited guest lectures. Over to you, ma'am. We welcome you. I request Dr. Sulochana Bhatt, ma'am, for a token of love.
Morning, everyone. It is very difficult for me to comment the second session after listening to a very interesting, interactive, and as Dr. Shrikanta mentioned, for the first time I'm listening to a talk on research methodology made so humorous, and so connected. I have been also giving talks, but I'm a very serious person. I have this compliment always. And it was very interesting. And thank you, madam, for giving me this opportunity. So I have chosen this topic because it is one of the area which is upcoming in allopathy as well as in Ayurveda. The last statement which Dr. Kulkarni has made is that it is time for us to generate evidence in Ayurvedic medicine. It is a very rich treasure which I got to explore when I worked in Natural Remedies Private Limited. It is a proprietary medicine we developed, but it was based on Ayurveda. But how Ayurveda can be modified and then made to suit, there's so many, modifications in Ayurvedic medicines, and where we need to be very careful. That is one thing. And is it only a research? No, it is our moral responsibility as a practicing physician. How many of you have actually practiced? Can you please raise your hand? Practice after your graduation? Have you been, I think, sir, your faculty, right? Yeah, that's okay. That's okay. Still, it's okay. Any students who have practiced? Any students? Okay, as interns, you have prescribed, right? Okay, how many times have you inquired? Follow up, you just prescribe, and then when you send the patient back, have you called up or asked him for follow up? And when you call them back, have you asked them whether they have experienced any adverse effects? Anybody, honestly, one or two? Anybody? How many yes? Okay, rest of you are no? Let's be honest. Yeah, because it is not a routine practice. We assume that whenever we prescribe, our job is done, and we assume that efficacy is also there, the drug is going to be effective, and it is 100% safe. Or if something is there, the patient will come back to us. So now that is not a very ethical practice. I want to bring ethics into safety monitoring. Safety monitoring is not only the regulatory requirement, not that we should report and they should have a database and then they should take action. No, as a practitioner, am I ethical in my practice? If I don't get to know what is happening to my patient with the medications which I have prescribed, this is our basic fundamental question we should ask. Ethics forms a fundamental core of clinical practice, both in practice as well as in research. So, we have 4 pillars of ethics which you already know about it, and it is 100% in the interest of our patient, right? So, all these are going to be part of your synopsis also. Autonomy, non-malpractice, beneficent justice, these are prescribed pillars. That means we must give the patient the right for his treatment. We should not cause any harm. I have picked up one very interesting shloka also from your text, which I'll be presenting later. And benefit should be there. Obviously, he has come to us for treatment, and there should be justice. When we do research, whatever research we do should be in the larger interest. So these are fundamental principles so that we protect the right, dignity, safety, and well-being of the patient. Whether in practice or in research which you are going to undertake, we must be concerned about patients as much as we are interested in the science. As much as we are interested in the science, there should be an equal concern for the safety and well-being of the patient. This has to be underlined for us before we take up our research. Now, ensuring patient safety. What does it mean? It means ensure patient safety from adverse drug reactions. Ensure the patient safety from adverse drug reactions. Why madam is telling so much about ADR? We have never come across because we have not observed. We have not educated the patient to report. And sometimes we are ignorant about the ADR ourselves. We don't know because there is always a changing scenario. So ADR is a silent. I am speaking from both perspectives, allopathic as well as Ayurvedic. Adverse drug reaction is silent but persistent pandemic. Have you seen side effects? Commonly, let me not talk about adverse drug reaction because this is a term which is recent. Side effects are there for Ayurvedic medicine? They are there? They are there. Okay. So ADR is a terminology which covers all the side effects. I mean, earlier we used to use the word side effect. Now it comes under the umbrella of ADR. We'll see what. Fifth most cause of death in developed countries. It is causing death, but we are not observing due to both Ayurvedic as well as allopathic. It may go undetected and undiagnosed. And in India, it is the 5th leading cause of death, the incidence being from 1.8 to 28%, as high as that. This is what is reported literature, and still there is a tip of the iceberg. So do you agree with this that herbal medicines are always safe because they are natural? How many agree? How many disagree? Okay, good. All right. So Ayurveda or Siddha medicines do not have any adverse effects because they are time-tested and used by millions of patients since ancient period. Don't we have data? In modern medicine, we do clinical trials, phase 1, phase 2, phase 3, phase 4, and we have pharmacovigilance. So it's the clinical trials are done extensively. In Ayurveda, it is being used. That itself is the evidence to show that it's used in human beings. But can we say because of that Ayurveda is safe? Can we say that Ayurveda? I'm not talking about proprietary. Can we say it is safe? No. How much of report is there in our text about adverse effects? Is it there, madam? Is there? It's there. Right? All natural products are safe as they are natural to human body, unlike chemicals. This statement also, I'm sure, none of you will agree. So by WHO, any medication which is intended to be used to modify or explore physiological systems is called as a drug. Can we call herbal medicines also as drugs? Ayurveda or phytochemicals or anything, any related to herbal, can we call them as medication or drugs? We can call them by this definition. So let's be clear about that. So there's one great statement, there's no safe biologically active. If it is biologically active, it has a potential to produce side effect. But there are only safe physicians. Physicians can be safe when we meticulously we can use our discrimination. So I'm going to fundamentals and then we go ahead. Adverse drug reaction, what the pharmacovigilance says is any response which is noxious and occurs at doses normally used in plant. Adverse event we use when it is not related with the treatment. So how do we know that if a patient is put on, name some Ayurvedic medicine, any medicine, ashwagandha. When you put the patient on ashwagandha, and let's say he develops epigastric pain or gastric, can we call it a side effect? Let's say the patient has come for stress and you have put him on ashwagandha. And maybe after 2-3 days he develops gastritis. Can we call it as a side effect or adverse drug reaction? Yeah, she said no. I agree with that. Why do you say no? How many say yes? He has developed gastritis. He has come for stress. He has been prescribed ashwagandha. After 3 days, he develops gastritis. Can we call it as side effect or adverse drug reaction due to ashwagandha? We cannot say. Yes, we cannot say because it could be due to stress itself, isn't it? So in such case, we call it as adverse event. When we do not know that it is due to the drug or any other cause can be explained. So these are the terminologies that are used when we ethically practice. Take it as our moral responsibility to monitor and report. So we must be aware of this. Therefore, I'm going with basic definitions. But what we are more concerned is what is a serious adverse event. So whether it was due to ashwagandha or not, there are scales. That's what Ayush also has given. Now, what is serious adverse event? You give the medicine, suddenly on the 3rd day, the patient dies. Or the patient has developed some disability, patient has developed some serious organ toxicity, which needs hospitalization. All these come under serious adverse events. These are the ones which the regulatory, the ethics demands that you report so that others are prevented. When we practice, if we are careful, when we observe and when we analyze, as sir was telling, observe and analyze and interpret and then send the report. That will go to the regulator, and why it is important is not to comply to the regulatory requirements, but it is our ethical responsibility so that we prevent other patients, and therefore justice is prevailing. Justice is a fundamental concept of ethics. So these are the definitions of serious adverse event. Now let's take a look at this publication. 45-year-old male patient took Ayurvedic herbal medicine for arthritis containing Enospora, Dania, and Comicora mucul for arthritis. And after 2 months, he presented with signs of jaundice, elevated liver enzymes. Any answers? What are the liver enzymes? SGOT, SGPT, right? Yeah. So, hepatitis A, B, C were ruled out because we have to rule out. Now, as I said, we want to see whether this is related to the medication or not. It was diagnosed as medication-induced hepatotoxicity. Patient was asked to discontinue, treated with steroids, and patient recovered after several weeks. Now, is it adverse? Can you say that it is adverse event or adverse drug reaction? Event means it may or may not be. We cannot say. In this case, is it event or ADR? ADR? Yeah? Yes. Why it is? First of all, when do we suspect an ADR? When do we say that this symptom could be due to the drug. Could be.
Hospitalization.
Not always hospitalization. Any area. Here hospitalization, yes. Right. No, in general, when do we say that there is an ADR? Any answer? It could be you have treated the patient, something comes up. When do you suspect that it could be an adverse drug reaction to the drug? Yes, very good. Then what's your name? Yeah, who answered? Yeah, I think we should clap for her. So first thing, temporal relationship. If that means it has to appear after that medication started. Then you start thinking about any other thing. Then we say due to the drug or without. Here, in this case, it is suspect ADR or AE. And then they started ruling out other conditions, hepatitis C, hepatitis B, hepatitis C. And then it's continued. And what was the final evidence to show that it was due to the drug? The symptoms is when you discontinue the medication, that is called as de-challenge. When you call it a de-challenge, then the symptoms will reduce. Any other confirmatory, anybody in pharmacovigilance may be doing anything else, how we can confirm? Now, still I want to confirm. Re-challenge, yes. And most of the cases we cannot do re-challenge because it is not ethical, right? So at this point of time, we need not prove that it is due to the drug. We assume patient, we have to be careful and we will not go by the science of re-challenging. We'll follow the ethics of de-challenging. We stop there. Patient has recovered, fine. Let's not get into that. And now the research can start on seeing whether this combination is always producing. It is there in the Ayurvedic text. It's a wonderful combination, I suppose, for arthritis. Then why did this patient develop? Is it happening in every patient? No, it may not happen. Same thing with allopathic medication also. It does not happen in any drug. So the ethical requirement or moral responsibility of practitioner is to go deep and understand why did this patient develop? Any reasons, any possible risk factors in this patient can you think of? If you are practicing, I have been giving this medication for so many patients with osteoarthritis. Why did this patient develop? Can we, this from here starts the such question. So why did this patient develop? Are there any more patients? Can I dig out the literature? And what could have contributed? Anybody can think of any risk factors for developing hepatotoxicity. Anyway. Right, very good, sir. Source of medicine may be faulty. Okay. What could be the problem in the source? Adulterated? Yes, very good. Anything else? Any patient characteristics? Alcohol, very good, very good. Alcohol can be. Alcohol is one of the. Anything else, right? Yes, sir. Who's that, please? Yeah, did he have any pre-existing? Very good, wonderful. Did he have any pre-existing? So next time when you prescribe, what will you do? You will do the LFT, RFT before you start prescribing. Right? So this is how we have to be always cautious. Any patient we see, it should trigger in us what should be the next, write down, document and start observing. And this will form the hypothesis. So anything else, any other factors, think about it, we'll come back to that. So this one also I found very interestingly that Shvitraharavati. For me, it is new. Excuse me, because my knowledge of Ayurveda is very, very limited. So they have found the skin reactions. I was surprised because allergic reactions we see plenty in the allopathic dermatology. Here it has shown, and then they have given the. Now see how this researcher has gone into Puranocomeris like solalin present in Bakuchi makes the skin hypersensitive and causes photodermatitis. It can, not on all. It can. So we must understand in some it will cause. So now we understand when you prescribe this, you should be very careful. How will you prevent it has said phytodermatitis. Very interesting. Photodermatitis to phytochemicals. This was something very interesting. Even curcumin is a phytochemical. Curcumin is also used topically. That also may cause, we never know. Isn't it? I don't know. Anybody has any experience with dermatitis with curcumin topical application? Anybody? We don't know. So, like that. And he found out what are the components of this preparation which are likely to cause. This is how when we explore. I mean, it brings a great validation to Ayurvedic science, which is very rich in a lot of therapeutic strategies, right? So why ADRs occur? I found in your text, in your reference, that it recognizes ADRs. I was wondering what ADRs is described. Shubhashri and I, we had discussed about this, and Madam also in our last meeting at Kanapura Road, we had your office. So it recognizes the concept of either ayog, atiyog, or nityayog, often linking like viruddha ahara or incompatible. Very interesting statement I found. And it also mentioned this yatha visham yatha shastram shukti vasa tatha naraha tathaushadham vijnatam viviktam syat pranashanam. Just as poison, weapon, hunger, thirst or fire can cause death, when not used properly, medicines not properly understood can be destructive. So this is exactly the definition of medication error, which we are doing NABH, NABL. So we have the source in Ayurveda, and because Madam gave me this topic and this opportunity, I went through. Otherwise, I had not searched. I came across it so beautiful. When it is overused, underused, overuse means depletion of the ADR is when it happens in the normal dose. But here I found, because my area, our company is working exactly on this. What is overdose? Generally, may not be over, what is normal dose for many may be overdose for some people. Yes or no? That is only precision medicine. They are calling personalized medicine. They are using proteomics, genomics, artificial intelligence to define what is precision medicine, because every individual is different. And so, therefore, precision medicine is exactly what Sarka Samhita has mentioned. And we have a lot of scope to dig into this. Now, I was thinking I should read more about this that will help in our own research, right? So, now let us put it in the modern terminology. What are the reasons? Some of you already mentioned that adulteration is one of the common reason for so where does that adulteration recently I deleted that slide because I thought it will be repeated. Even Loki juice we discussed last time, no? Ashford juice. Some lady who used to run every day for some 10 kilometers or something. Suddenly that day she collapsed. She died. Both consumed, I think no, the wife consumed and young lady in Pune, she died after consuming the same Ashford juice which she used to take every day. That one probably was contaminated, adulterated. The source, as you rightly said, that was contaminated. So there are many reasons. So the drug itself, Spora, Vidania, all those, the drug itself must have cost. It may be having the potential. Of course, it is a combination of the drug and the patient characteristics. It cannot be the drug alone. And that is the reason we don't get in all the patients. So drug can cost by on its own, but if it is not used properly, in that previous shloka we said, if it is not used properly, that means the drug itself has cost. It's a medication error, as we already mentioned, and patient characteristics. And very beautifully, now we are in tuberculosis. That's the area where I work. And since 5 years, we are observing whenever we advise a patient on lifestyle modification, the bioavailability has increased. That means pharmacokinetics. My subject is pharmacology, and I am passionate about how it is absorbed, metabolized, how actually does it reach in that range? Does the drug reach in that range in the blood? That is what is my research on. And we found lifestyle medications. And Ayurveda definitely says that medications are most useful with your restrictions, diet restrictions, and lifestyle modifications. So pharmacokinetics means absorption, distribution. If you talk with the modern terminologies, the receptors, receptors we call, you are aware of that, right? Pharmacology, drug acts through receptors. Expression of receptors improves with exercise. Classical example is insulin receptors in diabetes. Then it's upregulation of receptors. So there is all these modifications happen whenever there is an alteration of diet, but microbiome changes when you change your diet. And when I was working in natural remedies, the chairman, I don't know whether you know, he's called R.K. Agarwal, he used to call me for a meeting and say, Dr. Saab, sab kuch paid mein hai, he used to say. I used to laugh. 2000, that was in between 1999 to 2002. I used to laugh. My sir is telling it is in the gut. I was fresh from MD pharmacology. So I used to tell where receptors are there, metabolism is happening, what he's talking about gut. And today, gut microbiome and gut microbiology has become a key factor in pathogenesis of so many diseases including the gut-brain axis, anxiety, depression, everything is related to gut. So the patient characteristic is diet, and so there is definitely a need to approach holistically both the things. We have to, it's high time, right? And of course, that is about patient characteristics. And then we have a lot of tools, and we have shown the pharmacogenomics, what we call. And I think about 10 years back, somebody had said Ayurgenomics. I think you have Ayurgenomics. Genomics. And you are going to, based on your genetic profile, you will categorize your Prakriti, yes. So patient characteristics and then manufacturing defects. Manufacturing defects cannot be overlooked. And when you prescribe, there are different brands. No? Here also you have different brands because the same ashwagandha is manufactured. Same Guduchi is given by so many people. So how they manufacture? Are we going into details of their composition, characterization, standardization, and content of heavy metal? When they manufacture, all of them can come into the product itself. Yeah. Any metal contamination? Students, are you aware that? I'm sure you'll be aware what metals can contaminate. You do use metals for your treatment in a particular proportion with diagnosis. Any other contamination of metals, and which are the likely metals that will contaminate? Anybody? Students, anybody? Yes, very good. Somebody said that. Lead, mercury, arsenic. Very good. So these are, and it has become a standard to define the levels of these metals when we give the certificate of analysis, right? So metal, that heavy metals can contaminate, and that can come in manufacturing. And drug interactions, definitely drug interactions, because nobody is taking only Ayurveda, nobody is taking only allopathy. And people who take allopathy will not mention to the physician that he was taking Ayurveda. And same is true with Ayurvedic. Am I right or wrong? Right? Yeah. So then how will we ensure? We have to inquire. We have to ask, we have to ask and make a note of it, right? And then adulterants, as we said, adulterants, it's not moving. Yeah. So there are a good number of publications, and two ways we should see these publications. One is there was extensive description of Tinospora during COVID time, because that was a medication which was very widely used as a, for what we have used in COVID times. Students, yeah, immunomodulation, right? So, but then there came a big article, meta-analysis, retrospective studies, which condemn the use of Tinospora. So there will be bias on this study, right? Because we don't know, when you do analysis, you should take all the data, know what was the source, as sir said. Could be it was not a pure source, it was not prescribed in the usual dose, maybe self-medication. That is one side. But the other side is also there, that they are not free. So we must generate. So this study, they tested the 5 studies revealed that market sample they have analyzed. This is very interesting. They have just picked up the market samples, and then they have shown there are plenty of adulteration. And when you use such samples and then publish that Tinospora has caused hepatotoxicity, that it's not valid because it's full of adulteration. Now, where is the source of this why they are allowing? Because we don't have a strict regulatory control. We don't have strict regulatory control, whether here or in allopathy also. Antibiotic resistance is a big problem today, right? Yes or no? How many of you are you all taking? None of you are taking antibiotics. You would have taken, right? How many of you have taken from the pharmacy? Be honest. For over-the-counter antibiotics. Anybody has taken over-the-counter? You would have taken, no? Because you know it. I'm not saying that you weren't asking, give me tablet for upper respiratory tract. No. You know, I want to take augmentin, give me augmentin. That you have done? Yes or no? Yes. That means all the pharmacists are not under the control of the dispensing antibiotics. So it is a problem of AMR. It is at that level, right? So like that, we don't have control for our Tinospora also. Full of adulteration. They have tested they wanted to do, and like they wanted to check the phyto, I think maybe cordicolin or so many are there. They wanted to check and they found that it is full of adulterants and therefore it cannot be. So there's publication. And then this is one study published in Indian Journal of Clinical Biochemistry. So here, 45-year-old male software professional. He was admitted twice in a period of 10 days. Generalized weakness, vomiting, abdominal pain. 4 times treatment was unsuccessful. And patient has been consuming 12 Ayurvedic medications in the past 4 years for stress relief and maintenance of health. And all products were purchased over the counter. Look at that, 12. And these are about Ayurvedic. We don't know what allopathic medications is taking for stress, isn't it? You would have taken antidepressants, you would have gone to a psychiatrist. We don't know about that. Look at him, young 45-year-old male. So they identified what are these, and they identified, they attribute this for heavy metal poisoning. All the three, all of them had lead, cadmium, arsenic, mercury, and some they have given the trade name, brand name. Some they have not given. So we don't know which brands. So your Ayurvedic texts are prescribing a very classical texts are giving very good preparation. Very nicely you want to do. But what when it comes to the market, we don't have control. Then the blame will come on this is self-medication. Nobody is to be blamed. If it is prescribed by you, will you not be questioned if you have prescribed? Yeah, any comments on this? Anybody wants to comment, madam? Anything?
Familiar with the name.
Okay. Okay. So these are not classical. Yes, these are not. And what about this one, sir? Shulavaran, Jivati, all those themes. Gugulu is a classical. Gugulu is classical. What I'm saying, Gugulu is classical. Even in traditional texts also, those is prescribed, rational use is given, no medical, everything is there. But the company fellow, what if is adulterating, what if is doubling the dose, what is this extraction process or whatever, his formulation. Gugulu you formulate with some, I don't know, you formulate, not crude powder, right? You formulate with something. So at that point of time, just like we have brands in allopathy, this also will cause. So we have to create this awareness. Otherwise we will lose on the merit of Ayurveda. I am saying that. We will lose on the, because for chronic illnesses and stress, I have worked on product on Vidania in natural remedies. It was doing so well. I presented a paper also. It was called C not C, and we had designed a clinical trial with Nimhans, Dr. Chittaranjan Andrade. Very beautiful, very well, proprietary medicine. But we knew animal models were showing very interesting because everything was under control. Now that we marketed, and then somebody will manufacture, then what happens to the pay? What goes to the R&D? So it is our ethical responsibility to be careful about this. Okay. All right. What specializations they have taken? All these postgraduates, all subjects. How many in Dravya Guna Shastra? Very good. Big number. Okay. How many in general medicine? General medicine. 3. Psychiatry. Anybody is there? Okay. All right. So the combination should work now. Dravya Guna Shastra should interact with the general medicine and take up such projects wherein you will have a clear understanding about their functioning mechanism and all that, and you will take the clinical experience from them, and together you should work. This is very important area to work. So as I repeated this and you all said no, because as you rightly said, herbal medicines are not only Ayurveda. Ayurveda has been rightly also and wrongly interpreted and developed into so many. One is indigenous or local herbal medicines. Category 2 is herbal Ayurveda. 3 is modified or changed. 4th one is imported products with a herbal drug base. Even in the CDSCO, there are 3 categories. One is classical, the second one is proprietary medicine, which will use different process for extraction based on their scientific experiments. Third one is phytochemicals. And among these 3, which you think is closest to the allopathic medicine? Phytochemicals, isn't it? So they say phytochemicals must come under, it comes under regulatory. It has to go through the regulatory clearance. So curcumin is a phytochemical, and what else? Silimarin, I think, is also. Silimarin we use, extensively used Silimarin for hepatoprotection. Even in TB we are using it now. So therefore, pharmacovigilance is extremely important. It is our moral responsibility to be part of this. Every healthcare professionals should be part of pharmacovigilance. I'm telling it so passionately because I'm there from the past 20 years after the PVPI came into existence. So everybody should be part of this, and it's related to detection, evaluation, understanding, prevention, and physicians become a core personnel. The whole thing, and this we discussed. I think whenever there's a temporal relationship with an ADR reported in the literature with a similar drug, similar class, reduces on stoppage, reappears on reintroduction. So these things we must understand. Okay. Every student is given topic patient related only, right? All patients, all of them, right? Pathology you have, pathology no. You have pathology is there. Oh, very good. Microbiology is there. Very nice. All right. So, why I was asking this question is, everybody can relate in one way or the other to pharmacovigilance. Even if you are not doing it as your main topic, please take it as a small project and present it. Will be accepted easily for your oral presentation, poster presentation, and all. So, Ayush has come up with this pharmacovigilance, and they have a spontaneous voluntary reporting system for physicians and everybody. And you submit your individual case reports and collect as much data as possible from the patient. There's a Ashwagandha, introduced gastritis report, no. What is his age? What are his comorbid conditions? What are the drug interactions? What is the source of that medication? So whatever we discussed, no, so many factors which can cause drug reaction, all that should go into the ADR. How many of you will commit that you will report if you see an ADR? How many of you will commit in the crowd? Very good. Some of you are still okay. At least late today, and later we'll see. Okay. So report that to NCC or Ayush. And what to report? Unexpected. You don't know Ayurvedic texts have not prescribed. Suddenly this patient has developed. Because I think there is a statement in your textbooks also that it depends on the culture and the time. Correct me if I'm wrong. Different times, no? What was written then? Now it is not. Why do you think? How people behaved in your Dwapar Yuga and Kali Yuga is very different. It's different, no? Why? I'm telling grossly, but what happened 40 years back and today? From science, the genes have undergone changes. Lifestyle. Our life, we are sitting for 12 hours. Those days they used to work physically. So there has been a change in the internal homeostasis mechanisms, the genes, the proteins, everything has changed. Body has changed, has undergone change. So its response to Ayurveda also will change. Yes or no? Yes or no? So therefore, your contribution, you can also be as great as Charaka. No, why should we not be? My open question, why should we not be? Everybody has a potential to add on, isn't it? So why can't we also add with these knowledge, find out where this drug suits to whom? That is the whole basis of pharmacovigilance. It's not ban the drugs. It is to position the drugs. It is to see who will be benefited, who will have an area. Define that. That is extremely potential area for research. A lot of funding will come from Ayush. I'm willing to join you if you are interested to take up research in this area. So this is a suspect area reporting form. Similar one is there by Ayush. What they expect is 4 things. There should be a patient. There should be a reaction. When it started, when it recovered, what is the reaction? There should be all the details. Name, manufacturer, batch, come to your Ayush form. And then there should be a reporter. Then this will be called as a valid one. And I'm sure your institutions, they represent the different institutions. Is it? Okay, every institution has right? Center. So definitely you are the coordinator, sir, in your center. So anyways, yeah, you are there for all central pharmacovigilance. So you can report to Madam. Then that should be there. And this is for Ayush Siddha Yunani and homeopathy drugs. So this is extremely important. We fill up all this and then all the details, as we said, batch number, dose. What will Ayush do if you send this report? Any idea from students? When you send this report through Dr. Shubhashri, it goes to Ayush. What do you think Ayush will do? If you report that the death happened due to this preparation from Dabur, I'm just saying it could happen. Maybe I would have prescribed. So, any Dabur, Himalaya, any drug company, yes, that has happened, and you report. What will Ayush do, you think, or what do you think Ayush should do? Yeah? Please, yeah, students. Yeah, think about it. No? What would you do if you are in Ayush? Please tell loudly. No problem, no problem. Tell. ಹೇಳ್ರಿಪ್ಪ ಏನ್ ತೊಂದ್ರೆ ಇಲ್ಲ ಇನ್ವೆಸ್ಟಿಗೇಟ್ ಯಾರು ಮಾಡ್ಬೇಕು ಅವ್ರು they will very good. So they will investigate and they will start getting reports from elsewhere. Then they will see whether it is related to the drug or not. What is the frequency? Then do you think they will take some action? Ideally, they should take action on the manufacturer. Maybe they will visit them because they have to prove right answer. You have to investigate. So all these details are there. It's there on the net also, and Dr. Shubhashri will give you all this. And then there is a probability check which Ayush has given to diagnose whether it is due to the drug or not. Are there any previous conclusive report? Did it appear after the drug started? Did ADR improve when drug was discontinued? And did it appear when drug was re-administered? What are the alternative causes? We said no, ashwagandha. It could be gastritis, could be due to stress also. And was the drug detected in the blood? Are we able to detect Ayurvedic formulations in the blood, like we have for plasma, allopathic medicines? That is called bioavailability. Measure the plasma concentration. Can we measure the concentration? Some molecules, yes, we can, isn't it? That is how they standardize in the thing. And now I think there is a more, but it's very challenging because you have multiple molecules and we don't know which is the contributing phytochemical. So it is difficult. So that we don't do it in allopathy also because where is HPLC, where is LCMS? We don't have. We are supposed to have, we don't have. Right? My company is developing a bedside monitoring for this one. TDM monitoring. What we are doing is we are developing a device bedside which will measure the drug concentration in the plasma bedside, so that whenever we feel any ADR or dose is not there, immediately we should be able to do increase the dose. Again, you monitor. Now we don't have that facility. Anyway, so voluntary reports. I was asking this question. They generate a signal, alarming signal. Something has happened. Somebody died with ashwagandha. Never in thousands of years somebody died with ashwagandha. What is the reason? This company, this poisoning, this one. And when you rule out everything, no, something was wrong with the patient. So that means ashwagandha should be used carefully in this patient, such type of patient. So it will generate a signal. So information generated from pharmacovigilance. It will help in recognition of previously unknown areas, frequency, how common it is, and identifying the risk factors so that you avoid, and mechanisms, why it is causing. So we'll understand that. Quantitative analysis of benefit risk. Even if the side effect is there, ADR need not be always serious. Even if it is there, it's okay. I will take care. I will give him some juice and it will, but the benefit is higher than that. So that we will understand. And those are the information that you collect once you start reporting. So elderly female, 82 years, complained of severe chest pain, diagnosed as MI, 82 years. Not diabetic, not hypertensive, had 3 falls, 2 hip fractures, recovered all the 3 times after surgery at the age of 79. Medication history, ultraset on and off since 10 years, Anzac 0.5 milligrams since 30 years. 30 years of daily consumption of this. No side effect. That is my mother. Oh. And healthy lifestyle she had, perfect lifestyle. So no ADR. With ultrasound, hip fracture. Her second day she used a commode with hip fracture. That was her lifestyle. Role model for me. She is no more now. She passed away. So I bring it because she told us always to follow a healthy lifestyle. No extra food. No eating in between. Following a very spiritually guided lifestyle and very strong mentally also, physically also. So this is how she led. And that I always remember her and bring her because it is good for a role model for all of us and to advise for our patients also. Healthy lifestyle will prevent ADR. Healthy lifestyle will balance your physiological. I need not tell you are experts in that. We are very ignorant in that. I'm admitting very openly. We are ignorant about maintaining a healthy lifestyle. When disease is there, we go. Prevention, we are not. And that's why always, after my research also started, I'm a fan of preventive medicine. Prevention. And Ayurveda means prevention. Right? So, generate data. What is the scope of research? What all we can do? What is the research gap? Generate data on ADR, on important Ayurveda preparations, which we commonly use. Identify patient risk factors, variations in dose, genomics, how doable they are. These are. Proteomics, I think, sir, has from Prayoga, right? So we have such, I've heard lots about Prayoga and all that. We have such, and IIC, we are in IIC. So collaborations will tell us more about, and we should get there. We did with lot of struggle. I did one pharmacogenomics in tuberculosis. It was so satisfying. In Ramnagara district, we are staying close to Prayoga only. In Dayanand Sagar, we found out that all our patients, 50% patients did not have adequate anti-TB drugs in the blood. So death is there, recurrence is there, and loss of follow-up is there, ADR, so many things. We found out with ICMR Chennai, we did the study. And we did genomics also. 50% of them are not able to metabolize. There are fast, rapid metabolizers of isomers. Like that, as I said, the body has evolved. We don't know about the genetic. If you can link Ayurveda with genomics, wonderful study, and you can have a lot of evidence there. Identify contaminants and can we use artificial, they're already there. I think they've started. Artificial intelligence to predict ADRs is there in allopathy also. Ayurveda also. Yesterday we had a discussion in ABLE. It's called Association of Biotechnology-led Enterprises. Kiran Mujumdar and all that. This was very important. Somebody raised this. Can we use AI in Ayurveda? Excellent application. And I'm sure SVS is doing this. SVS is doing lot of characterization of three prakritis. Not only three prakritis, they are using this for Sattva, Rajas, Tamas. And that was something, I didn't know this, that you can quantify the metabolome of Sattva, Rajas, Tamas. Because I am into spiritual this one, and I was so surprised and astonished that SVS is doing that. That each of these personality, you can see the phenotype of that. That means how they manifest in physical characteristics. All these very interesting experiments Ayurveda can bring up. There's a lot of them, and can AI be used to predict adverse drug reactions? So that is what it is. Key takeaways are monitoring and reporting is essential for ethical clinical practice. It is must. Take this message from me. Many people are there. I am here to just give this message. Pharmacovigilance is challenging as each preparation is composed of multiple herbs and each herb of multiple active principles. Contamination, wrong identification, adulteration, pesticide residue, and heavy metals contribute to the causation of ADR to herbal drugs. Similar things happen in allopathy also. Collecting complete patient data on ADR helps establishing causality. You can add your Ayurvedic description of patients also. I don't think that is there in Ayush, madam. Is it there? Prakriti, is it there in ADR form? I didn't see. So that could be a modification, no? Isn't it? So that is how we can, this idea stuck to me, that definition of patient Prakriti is unique in Ayurveda. Why shouldn't we bring that in ADR? And good pharmacovigilance practices involve a shared effort from hospitals, physicians, patients, vendors, and regulatory bodies. And William Osler said, as soon as you give medicine, you must recover twice, once from the disease and once from the medicine. Because every medicine has a potential to cause adverse drug reactions. Thank you so much for your patience. If time is there, we can take questions. Time permits. Open, don't hesitate. Kannadadalli open.
Hello, sir.
Language is not the thing.
Hello.
Patients are important, isn't it?
Hello, sir.
Any questions?
Is it allowed, madam? Questions is allowed. Hello.
No questions?
Hello.
Does ADR happen at normal dose or overdose? Normal dose.
Hello, madam.
Three factors that cause ADR. Anybody, students? Three factors
Hello, madam.
that can cause an ADR that are responsible. Adverse drug reaction, ugly care. Four factors. I put that picture. No?
Hello.
Adulteration, yes.
Hello,
Overdose,
sir.
okay. Overdose means individually, yes. Anything else?
Hello.
Anything else? Pardon? Heavy metals, yes. Patient character.
Hello, sir. Hello.
Thank you so much for awakening and very interactive session. I request Dr. Shubha Shivan,
Hello.
give her a token of gratitude.
Hello. Hello. Hello.
We need to break for tea. Within 3 minutes, please everyone be back. Same place, breakfast place when we had same place. Please be quick and come fast for the next.
Yeah.
Here.
Yes, you can. No, no, no. What is it?
ಮೇಡಮ್ ಬರ್ತಾರ ವೇಟ್ ಮಾಡೋಣ
One more.
After a short tea break, we are here for a power-packed session from Dr. Swaminathan sir. I'm very honored to introduce him to all of you. Dr. S. Swaminathan is the inaugural chair and professor of nephrology at Indian Institute of Science, Bengaluru. He joined Indian Institute of Medical Science in December 2023 to help establish a new clinical and research departments. He previously held the prestigious roles as Senior Associate Consultant and Associate Research Chair at Mayo Clinic, Arizona. His academic foundations include an MD and a nephrology fellowship from Postgraduate Institute of Medical Education and Research, Chandigarh. Dr. Swaminathan later completed advanced fellowships at Mayo Clinic College of Medicine between 2003 to 2006. His primary research focus involves studying iron metabolism and its key role in kidney injuries and systemic inflammation. He is the leading expert on ferroptosis, investigating how iron-mediated cell death affects organ failure. At IASD, he leads a dedicated laboratory that utilizes 3D organoid models and animal studies to discover new therapeutic pathways. Throughout his career, he has received many honors. To list one of those is the Red Star Award for his excellence in medical education and clinical mentorship. Beyond research, he is committed for frugal bioengineering to make kidney disease diagnostics more accessible in resource-limited settings. We are deeply honored to hear from you, sir. We welcome you on the stage.
So good morning. Thank you, Sulochana, and thank you, everyone, for having me here. And I'm very glad to meet all the students here who are here to listen to this talk. Is it okay? Is it better?
No.
Yeah. So, so I've been telling my students, how I'm preparing for this talk. I was in US, for 10 days, and then came back. So my students are really worried, sir, have you prepared? So they come here to check. So, on a side, so it's such an exciting and important talk. And I would rather say I feel very fortunate to be given this opportunity to give this talk. And I owe this to our rishis, ancestors, and all the classic wisdom that have been bestowed to us in this country through thousands and thousands of years of deep philosophical thinking. So now let me start a little bit. I mean, the talk is going to go all over the place, so you need for that, because it will be very hard to capture Vedas, very hard to capture Ayurveda, and it's going to be more of glimpses. So it gives you inspiration as you think through this, and what all ways you can think about this. So this is the kind of, you all know how the Ayurveda came about. From Brahma to Daksha Prajapati to Ashwini Kumaras, Indras, Bharadwaja Rishi, Athreya, Agni, Vesha, and Shara. Here we have two Shara. So Rigveda is replete with shlokas or mantras for Agni, Indra, Ashwini Kumaras. So you can just think about it, that if that is the origin for the whole thing, then Rigveda forms the essential foundation. Eventually, Ayurveda, Atharvana Veda. So, but that is the foundation for. So, if you're going to go into the glimpses of that, it's going to give very profound insights how this thought about medicine actually came about. And if you're going to understand this process, then we are going to understand everything that we are thinking so-called modern science. Because this is the foundation on which modern science really came. So now let us step back and look at the word doctor. So that is the word doctor. So I studied for 18 years and then practiced for so many years and all that. Here I am. And then, we take this Harrison's classic textbook of medicine. And in that, there is a thing, that the word doctor came from everybody wants to. And they say that it's derived from the Latin word docere, which means to teach. So I kept telling all my students in PGH Chandigarh, in Mayo Clinic, whenever I went, okay, doctor is supposed to be a teacher. That's what it is. Until 2 months ago, this inspiration occurred one fine day. I don't know where it came from. Then I was just sitting and then seeing that I was listening to the Puranic story of Daksha Prajapati and Sati Devi and his own yajnas and what happened and everything, and his connection with the Brahma and Shiva. Right? We all hear about it, and how the Shakti Peeths came, the 52 Shakti Peeths in India. So then suddenly it stuck. What is this story really telling us? I don't have time to go into this, but it is given profound insights. But that's where the word Shara is the likely source for origin of the word doctor. So we call it as doc. That is Daksha. So what is the meaning of the word Daksha? Daksha is somebody who is skilled who's dexterous. The surgeon has to be dexterous, skilled, intelligent. So that is the likely origin of the thing, and it's not been published anywhere. It's not something Google Gemini gave, something you have to tell the world. But the story of the dossier Latin has been told over and over and over again. You go and tell this new thing, for people to really believe that this is the most likely inspiration here. But there is something even more exciting. If you look at Daksha, it's connected to the Dakshinya. So Dakshinya is passion. So what is the attribute of a doctor? The key attribute of a doctor? Passion. So now Daya and Dakshinya, they go together, isn't it? The internal empathy is Daya. And the external grace. So what do you look at as a doctor? In Mayo Clinic, they say that, oh, he's got like bedside manners, they call it. What is bedside manners? Bedside manners is nothing but external grace and conduct. The way you talk to the patient, the way you touch the patient, your slight movement of the face, you express your emotions, right? And how you really connect with the patient at every level. That is Dakshinya. That is bedside manners. So Daya and Dakshinya define acquisition. And that takes us to Dakshinamurti. So Dakshinamurti is facing the south in the temple. This inspiration came later. So now Dakshinamurti is sitting in Mauna in silence. So when you're a doctor, you have to listen in silence. You're going to have like thousands of flattering thoughts. You're not a good way there. You have to pay like unadulterated attention to your patient. And you have to remove false impressions, which is apasmara. So Dakshinamurti is crushing apasmara with his feet. So the ignorance or the false notions or the wrong knowledge that you have has to go away. Right? And you got the Sanat Kumaras who are the mentees sitting around you. You're conveying that deep knowledge. Right? So that is the connection. So that is why Dakshinamurti is called Adi Guru. He taught Yoga Sastras to the world. So Yoga and Ayurveda, they're all connected, isn't it? So that is the inspiration behind the word doctor. So now, the second construct is the healing touch of a physician. Everywhere you go, people talk about, AI is not going to replace it. Because you need it. Just touch the shoulder. Let's say, Sakti ko jayega. That word is enough, the patient will take that. Whether you cure the patient or not, he's going to believe that he's going to get better. And he actually gets better. Right? Where that inspiration comes from. So go to Sri Rudram. In Sri Rudram, we have this. Aste Vibhradveshaja. Varyami Sharma Varna Shakti. In Southern. That is the Sri Rudram. So Haste Vibhradveshaja. Veshacham. The healing herbs or healing remedies. Haste. So it talks about Rudra. But the divine physician is the Rudra himself. Isn't it? So if you're kind of purified yourself and to the way where you attain that siddhi, so hands have the ability to heal. So that is the inspiration from Rudra about the healing touch. So now, how is health defined? So World Health Organization defines it as a complete physical, mental, social well-being, not really an absence of disease or infirmity. Just keep this in mind. It's talking about physical, mental, and social. Okay. But then Ayurveda has given a much better and a complete description of what is that. Dosha Samadhisha. I don't have to repeat this here. Samadhatmana Kriya. Prasanatma Indriya Manaha. Pastat iti Vidiyate. So it's actually, it actually talks about mental wellness. It talks about Samadhatu. It actually goes to the level of tissues, right? Or the organ systems of tissues. Sama, they are in a homeostasis, right? So they are in a balanced state is a very rough term. It's a homeostasis. So they are in a homeostasis, neither they are in excess or in, deficiency and so on. So all the things, they are all together. Sama Agnischa in a broad way, but it's also your being and all the aspects of Agni. We can talk about Agni for I don't know many hours, but Agni is everything. And so that is the beautiful kind of a concept that has been captured by Ayurveda. So what the point I want to convey is Ayurveda and Ayurvedic physicians, they are millions of years or thousands of years ahead of modern science. So we don't have to look upon a modern science to validate your observations, but rather stand with that self-confidence. You've got something to tell in modern medicine. I think that is the truth in this whole story. And as Professor Navkam mentioned, the more we dwell into this, the more you feel inspired. And every little word can convey. It's beyond what has been translated, believe me. And maybe very famous authors, the books you may read, and so on and so forth. But if you go with the pure state of the mind, if your siddhis are activated, when you're going to go and read those same shlokas, you may get an inspiration which nobody else had. So that is the state of mind I want you to look at it. I think as because these are your issues. So now a little bit about the Vata, Pitta, Kapha, three doshas. I won't be able to cover everything. So just going to give you a little bit of a glimpse, right? And some of the foundations of Ayurveda you talk about and Saptadhatus and so on. Saptadhatus, I wanted to do something, but I didn't have time, to cover, within this talk. But a little bit, I'll just cover, that because you're talking about, connecting with the modern sciences. So let's say that Kapha is something that holds together in a broad manner. And it's connected to Ojas, one that lubricates, resistance to disease, relevant in regeneration. Okay. See, that's why Kapha Prakriti has a longer lifespan. We all go through wear and tear, but the wear and tear, how it gets repaired, is what determines how long we are going to live. So if you have a Kapha Prakriti, which dominates, you have the ability to heal yourself. So that's what leads to longevity and the Ojas and strength and longevity. That's the kind of connection here. So now let us look back from a modern medicine perspective. So for example, if you take the mucus layer in the intestine, which is a classic kind of a thing, 1,000 different types of molecules there. So that is a Kapha. And then there is the mucus here, and then if you have a problem with that, you get like all kind of inflammatory bowel disease. So anyway, little glimpse here, but then if you just start thinking this way, you might actually find that, okay, there are mutations that affect the enzymes that produce the mucus might end up getting connected with inflammatory disease. Right? So that's the way that you start thinking. And how does Ayurveda really look at really rebalancing? That might give a clue to kind of reconnecting back to the modern science perspective. And you may end up finding that there is a way to really course correct in inflammatory bowel disease. See, right now, all treatments for inflammatory bowel disease are targeted against the human inflammatory cells. You give like very costly monoclonal antibodies, one destroy the immune cells, then it gets better. That would be a better way. Okay. So that is the kind of thought you need to put in. You have to believe that there must be something that actually kind of do this in a better manner than see the modern medicine, the way it is going. as much I'm a scientist and working on all those type of things, it is not sustainable, isn't it? We are going to have a treatment which is costing, 100,000 US dollars. Who's going to pay? Okay, most of the people cannot, and it is just not sustainable. So we really have to think, right? And whatever it is. See, rishis did a lot of work, but I'll tell you, we have failed to do that much work what rishis did over the last 500,000 years. We took all that and have sat on it, and we haven't done the tapas. I won't say that knowledge is different, tapas is different. To kind of really take that interpretation even further, because that is why rishis created this. So we need to take it to the next level, not by reading textbooks and reproducing it. Trying to attain the siddhi which rishis did to get a deeper understanding of the subject. So now, again, the pitta. So we take it's connected to the tejas, cellular metabolism, thermogenesis, right? So if you go and look at what Ayurveda has done with brown fat, right? Not many papers, not just to kind of look at it. That's an example, right? And you're looking at thermogenesis. For example, what happens with hibernation? Right? Animals go into hibernation and then it protects. So what really happens here? With that. So there could be some very fundamental questions you can ask to understand this process. And then you look at the human studies I'm talking about. So there are ways now you can scan the human body and then say that how much is the brown fat which is there in different parts of the body. And then that can actually tell you that what is the thermogenesis, which means that you've got more metabolic treatments. Right? So let's say that there are Ayurvedic treatments which can actually induce this, that we know. Have we done studies to look at that type of a scan to look at the brown fat distribution in human? I think there are zero studies. Maybe some studies in animal, but there are zero studies. Just to give you an idea that we can do. Then determination, passion, and see again. One thing beautiful about Ayurveda is that the mind-body connection comes through and through, which modern medicine started talking about in the last few years. What happens in the body happens in the mind. What happens in the body happens. It's really tough. So, and then anti-infection immunity. And this is very interesting. It's fire and the oily aspect of the liquids. It kind of conjoins, to create more of that in that component. Fire is the predominant component, let's say. So now it is actually connected with the reactive oxygen species. It is connected with the reactive oxygen species. It's just not, we are looking at digestion, and we are looking at digestive enzymes and so on. So we need to start think about at a cellular level, at a molecular level, at organelle level. So we can devise organelles into Kata, Kapha, Vata, and Pitta. We can go into the molecule, we can go even at every level this division goes through. So then that creates a very different type of thinking. Right? We are not just looking at the super Sharira, just the cross. Right? Looking at the Sukshma Sharira, and you're so that is the type of journey we need to take as we think through this thing. So for example, the proton pump sitting in the gastric apparatus cell, which is digesting. Do you know where the action takes place? The H plus ATPase? It's in the lysosomes. So lysosomes are the stomach of the cell. Because it ingests everything, it digests everything. So if you give a starch particle, it goes to the lysosomes. Everything it engulfs, it goes to the stomach. Like that, the lysosome is the stomach. So if we are talking about anything concerning the digestion and so on and so forth, then it connects to the lysosomes. That's what Rishi's meant. Ayurveda said every cell is the source of intelligence. Every cell is like the entire human body. Right? So we need to look at the cellular level. Then it's going to lead to hypothesis, which we are not. So now Hridroga, let's take an example of this. So now again, if you go here, the Hridroga Nidana, and what you're saying is Ati Ushna, and then you can say Ati Guru, right? So you keep going, and then it say the third line, Chinta, right? So and then there is also exercise, eating, all of that is there. So what causes heart disease? Anxiety, worry, not sleeping, excess eating, right? And Adi Guru, heavy food, McDonald's, right? So you go there, on the Brigade Street and all that. I feel sick. I see 20-30-year-old standing with the plates of fried food, eating at wrong time. It's there. At 11 o'clock to 1 o'clock. And then when you should not be eating. And then we have a 35-year-old software engineer dying sudden death. This we already said, in Ayurveda. So now the thing what Ayurveda goes on to talk about the Samprapti of the Hridroga, it talks about due to the exposure of those nidanas, doshas get initiated, right? And then the key thing it is kind of talking about is actually rasam dosha. So it's the rasa dhatu, right, which is kind of the key thing that gets affected. So what is rasa dhatu? Rasa dhatu is, let's say, plasma, lymphatic, and nutritive fluids which flows, and it's primarily driven by the dhyana, right, which kind of circulates and goes everywhere. That's what we do. So now rasa dhatu has got its liquid, it's unctuous, liquids, and then its flow, shita, it puts the fire down. It's like kapha-like characteristics, right? So it's important for nourishment, immunity, and circulation. And it's also an important nutrient for your, which is the hematopoietic system. What is hematopoietic system? It is your immunity. All right. So just to keep this in mind, now I'm going to go to the other slide, which is the modern medicine. Here we are talking about what causes cardiovascular disease. So look at what Ayurveda said, lifestyle factors, stress, physical inactivity, Western type of diet. Okay. Our acharyas told 1,000 years, 2,000 years before. Okay. And then they said, okay, all that. They talk about that. Some of the other uncontrolled other diseases also comes in the shloka. And then, various other things. And then it leads to the thing. But then the key thing to look at it. Right? So there is metabolic and epigenetic changes, innate immune cells and precursors. So what happens? You have a trained immunity. Because you do all this, it kind of activates your immune system, the hematopoietic system, which is the Rakta Dhatu, get activated. So the Rasa Dhatu has got lipids and all kind of inflammation. And then that leads to a trained immunity, meaning like they get memory, they come and keep infiltrating the blood vessels. So the connection between the Rasa Dhatu, the lifestyle to Rasa Dhatu, the connection from the Rasa Dhatu to Rakta Dhatu to Hridroga, a cardiovascular disease, has been beautifully captured in Ayurveda. Okay? You put these two together, just imagine that they should be written. Right? We should actually take it forward and really see. And there are clues, some fundamental clues here. So the lipid connection, right? The guru, Adi Guru, and then Rakta Dhatu, Rasa Dhatu, excess lipids, right? And then the diet and everything, the fats and all that. And then it's making the thing split down, and then it is activating the hematopoietic system, upsetting cardiovascular disease. So now, Hridroga and Surya, what is the connection? So I bring this up because in Rigveda, there is a mantra we recite during Sandhyavandana. It says, Hridrogam mama surya, Harimananchanashi. So Hari can be called yellow. Hari can be called as a little bit green, or Hari can be a little bit weakness or shade. So just face it. Hridrogam, Surya. Surya is important part, the Hridroga thing. So now if you look at it, beautiful studies have shown there is a missed study where they looked at sun exposure and then they saw that solar exposure reduces all cause mortality. It reduces death from all causes of death. And so that's a little bit of that in my show. And now we all know that sunlight can cause UV damage, skin damage, and all the bad things, but we didn't focus on good things. We want vitamin D, isn't it? But what is most important for the heart? It is the blood pressure. So it turns out sunlight exposure. There's a 2017 and 23 paper published in a top journal. One is in Scientific Report, other one I'll show you in the next slide. That the skin cells on exposure to sunlight releases nitric oxide, which causes dilatation of your blood vessels. Okay, that takes us to the next slide. But in addition, it also activates various other good things here. Melanocyte-stimulating hormone, it activates like oxygenase 1. So there are like multiple benefits that happens with eating. So now you can say that why did our rishis in Rigveda said, Hridrogam mama surya harimanachinachi. Okay. So now if you go to the next slide, so this is some nitric oxide in blood pressure. So relative to the exposure to the sunlight, nitric oxide goes up on the y-axis. And as the nitric oxide goes up, you can see the mean arterial pressure is the lowest where the nitric oxide is released. If there is more nitric oxide released, less is the blood pressure. So that's again what is the effect of that. And this is the circulation research paper. Okay. So this is the paper I was referring to, avoidance of the. So now a little bit about, I'll take the other course here. I don't know how much time I have. But so far we've given some glimpses from Vedas. A little bit about Upanishad. Here we talk about various koshas, Annamaya kosha, Manomaya kosha, Anandamaya kosha, Pranamaya kosha, Vijnanamaya kosha. So again, cultivating conscious eating, is fundamentally important. Ayurveda has spoken a lot about what to eat, when to eat, what season one should eat what, and what one should avoid, and based on the prakriti and all that. So essentially, Ayurveda has taken this and they put it in their blog. Okay. Tell me one Indian modern institution has taken this and put it in their blog and said that this is what everything gets converted into. Very unfortunate, but the point is that the good things are not being conveyed, and this is the thing. So what you have to do, and you don't talk, you're eating. You sit silently, you sit on the floor, and there is a reason why you sit on the floor. How people learn to only sit on dining table. They get like osteoarthritis and all kind of problems. So basic things. So now, again, if you go to the Bhagavad Gita, you have that, the Brahmarpana mantra, most of you know. Prana, Pana, Samayuddha. So essentially, it is the balance of the pranas, which is so essential, that is important for Aham Vaishvanaro Bhutva. That's the Agni. So this is again from the Annakala, from the Ayurveda. And again, beautifully it says, even you don't even hold urine, you empty your bladder, empty your colon and everything, and be in a very relaxed homeostatic state when you're consuming food. So there is a balance of the sympathetic and parasympathetic. So you're not having 110 heart rate. You just argued and fought with your server. And then you go and consume food. Your body handles it very differently than when you are in a very balanced fight state. To create that space around you to eat, that's what they kind of very beautifully kind of convey here, and what is said here. And the power of intermittent fasting. The beautiful stories, the story of Rukmangata. So essentially they say he was fasting on Ekadashi, which is like twice a month. So then the story says that Yama became jobless and the wells were empty. And earliest observations suggesting that fasting would actually help with preventing mortality. Okay? So that's how they kind of weaved it into beautiful stories to convey to the public. And there is fasting across cultures. So people have adapted it. And so we must appreciate that it happens. And then metabolic adaptations to fasting, and anybody's interested in read what the signaling changes that happen. It's a beautiful paper in New England Journal of Medicine. And again, there are more papers, the long-term adaptations as well, including improvement in insulin sensitivity and resilience and disease resistance. Now we go to the second one, breath. So why breath is the key? Because kurmo sounds addictive. So essentially it says, like the tortoise lives the longest because it breathes the slowest. So the number of breaths you take determines the number of years you're going to live. Right? Every day we take 21,600 breaths. And then that is why in yoga, pranayama and breath control is advised. You reduce the number of breaths you take. If you're in deep meditation, do you know how many breaths you take? Like normally you take 12 breaths, per minute. In deep meditation, some people, yogis can go to samadhi. I'm not talking about that. But you can drop it to 4 breaths per minute. So if you cut your number of breaths by 1/3, you increase your lifespan by 2/3. At least you'll increase your lifespan by 1/3. It's not just lifespan, it is health span. You live health. There's so much effect of breath that has been kind of conveyed. So now what happens? We are not doing it. So now USA described a device to slow the breathing with the biofeedback, and they're selling it for few dollars, whatever dollars, and it is FDA approved and given to people. Okay, so now another thing, people will question, what is that doing this memory? Right? So the point is that there is so much scientific validity behind all that. There are some very nice papers how that affects the sensitivity and really improves the research application. Various types of pranayama I would go into detail. So now go to the story of Markandeya. This is truly amazing. So again, his Alamtaka is in there. Markandeya was supposed to die at the age of 16. He was hugging, Shivalinga, and then he never died. Right? He couldn't be killed. So that's you go, and now what happens in Tripura, let us say you get the details. It turns out that yogis who practice the control of breath on the fate, even fate cannot impose its rules. That's how much power that is. That's the story behind Markandeya Purana. Tripura, let's say, on Sunday. So a little bit about the breath, and then Bhagavad Gita stories and duality and all that. So now about meditation, about the Manomaya Kosha. So this is a paper that this was done in Peter Peters, my friend, in Netherlands. There was a yogi who came and said, "You inject bacterial endotoxin into my body." He challenged that my body will not react. So Peter Peters got permission from the government and then got out of this yogi. This yogi meditates, he practices pranayama, and he walks in ice water. There is a procedure he follows. And then Peter Peters did the experiment with 1:1. And then it turns out that his body is not reacting. And they gave all that, they looked at norepinephrine and epinephrine. They looked at various cytokines, everything. He is not responding like the other person controls. So then they got permission to do more number of people, and the yogi trained. It's called third eye meditation. And the data was consistent. And this was published in the prestigious Proceedings of National Academy of Sciences with an editorial in 2005. Right? So that is the power of breath and mind control that you practice. It's got a profound anti-inflammatory effect. Now we all know that there is a nicotinic anticholinergic pathway. The vagus is one thing, but 1,000 ways mind and body. Okay, that's a beautiful study here. And then there is large-scale genomic study looking at inner engineering relations until and I have classmates and this showed the genomic level, what are the differences that happens with meditation and yoga and pranayama practices. Fantastic data, to really look at. And there are changes in the brain waves, as you know, with meditation, and I will spend more time here. And So, so again, what is Shiva? The blue represents the stillness of the mind and breath, right? And the cold exposure stimulates thermogenesis, right? Cold exposure is one of the ways that you induce brown fat in your body and all that. So they presented it all in a beautiful way for us to understand, right? And that's why they say some yogis don't need a dress, no, when they walk in the snow, because they have brown fat. You go and scan them for the brown fat, you'll find brown fat everywhere. So that's the story. So it's all like, there is a very beautiful basis for all that. So again, description of sleep and consciousness. So again, Om itself, people talk about the states of their consciousness. So essentially, it's there. So again, little bit I want to, this is from, again, Ayurveda. There's something called Ratri Suktam. So it talks about night, Ratri is night. In that Suktam, they talk about, Upama Kepisha Krishnam Yaktam Astita, Usha Rinenga Yate. So he drives the thick black sheet of ignorance, inert. That's the thing. And the first way, Yavya, Vrikya, Amritain, Adayasthena Modi. So it says Urmi, right? Urmi is what? Wave. So sleep was characterized as a wave in modern EEG 50 years. Rigveda captured sleep as a wave, I don't know how many thousand years. Okay. And then it says, Pepi Shattama Krishnam Vyaktamasti. Black and inert removes. Now, within the last 10 years, we have found that amyloid accumulates in the brain and sleep removes the amyloid. So that is the essence behind this. So again, reduced sleep leads to Alzheimer's disease. I'm going to split this. And again, I'm going to just split this, for the sake of time. And if we talk about caduceus as a representation of medicine, I believe it actually is connected to therapy. Okay, and so for the sake of time, I'm going to just miss it. It's actually completely connected with Ida Pingala and the thing. And many of the connections I can keep going on seeing. Apollo, god of music, and rides on swan. Swan is Hamsa. Hamsa is the in-breath and the out-breath. That's why we call it a Soham Hamsaka, Soham Hamsa. So then twin forces in Apollo and Artemis born with Zeus. So that is in Greek mythology, but they are nothing different than twin humans. Zeus, the Greek god, is actually Deus. Deus is like the sky. Okay, so it's all connected. The world is much more connected than what we think that we are. So again, I'll skip this and the cost of medicine we spoke about. And, it's all about devotion, and you have to really have adverse laughter, attitude, everything. It all has to benefit. And again, you need to have self-compassion. And then I say that focus on the work rather than the outcomes. Compassion for yourself. Don't compare yourself to anybody. It's okay. So believe in those. And so again, Bhagavad Gita has beautiful lessons. And never blame yourself. Right? In fact, like yesterday, I was quoting something on Mani Sutta. This inspiration came like 2-3 days, so I shared with some of them. So in that, like they say that in Mani Sutta, they say that Kama Akarshin, Manura Akarshin Namo Namaha. So Kama Akarshin, I'm not responsible for the desire. I'm not the doer. Manura Akarshin, I'm not the cause of anger. Namo Namaha, you're saying. So what it does is that it does exteriorization of the emotions for you. So this is the foundation for cognitive behavioral therapy, which psychiatrists use today. So this is actually described in the humans. So again, where Ayurveda and modern medicine can come together. So this morning I was reading, Mayo Clinic collaborates with another thing for $28 million to regenerate liver outside the body. They're going to put hepatocytes, stellar cells, and all kind of cells to make a liver regenerate and then put it back to the patient. But the way I'm seeing is, you got like tremendous herbs, Pilatus, Niruri, all kind of hepatoprotective herbs. And so, what is the role it's going to have, right? Do we need to spend $28 million, right? Or maybe it's those two. maybe we have a much better and effective system, just in terms of ideas. On one side, we may be doing genetic engineering. On the other side, we are looking at herbs. And they all come together. That's the opportunity we have in India to bridge the classical wisdom with modern science. Whether we can challenge anyone in the world if we're able to do this, right? And we can bring the cost down. Rather than each one liver costing 3 crores, we'll make it for 3 lakhs. And then we'll give America. You know, I mean, really, that's exactly where we are going and we should be going. And, you know, how we are going to interpret this knowledge and, you know, how much wisdom is there in Ayurveda, just modern sciences. So, so knowledge is a continuum. See, you know, Rishi started somewhere and then they left it. They left the treasures of material. I mean, I wanted to talk about magmas, I wanted to talk about Adi Shodhana, there's some other things I want to talk about. But, you know, because I may not have time in my lifetime, you know, that's how much Rishis have given. But, you know, we need to take all that. So this is the last one, a couple of slides. So this is the first sutta of the Ayurveda. It starts with Agni De Purohitam Yajnasya Devam Ritvijam, right? So the Agni, so Agni is everything, right? In the metabolism, you can say various different things you can say. And but that's the essence, that's a force which is driving everything. It's a purifier, it's the ultimate purifier, right? It gets it, right, to make it pure. But then what do you do with all that purity? Here's the last sutta of the Ayurveda, that is called Samana Sutta. And it says that Samana Pratayani Samanamastu Vomano Yadhavas Sukha. Right? So it says that let it all come together, parts come together, we perfect union amongst you. So this you can apply within an organ, this you can apply within an individual. So let that be a union between the heart and the kidney and the liver and the brain, all that. They all have to work together. And who is going to bring that unity? I believe. And then it could be between you and the other person. So because there are, you know, I don't like you, I don't like this. He scolded me, if you remove all that, that's agreeing. Then you come from compassion. You come together. So the more you are integrated within, the more you are going to integrate without. Right? So that is why swasti is the swasti of an individual, is the swasti of the society. And swasti of this universe. So that's the responsibility. And so I'll stop here and thank. Science is just a deeper inquiry to understand the Satchita. As we grow within, you know, everything automatically manifests. That's why Ayurveda came from Brahma, right? Because it exists already. And so I'm thankful to Rishis, Gurus, divinity, everyone here, my students.
Thank you so much for igniting our minds for analytical thinking to move forward in research. I would like to request Dr. Yodmani sir to felicitate Dr. Swaminathan sir. So please come on the stage to receive the token of love. Yes, sir. Our next technical session, we have our speaker, Dr. K.S. Nagabhushan, sir. I'm very honored to introduce Dr. K.S. Nagabhushan, who is an interdisciplinary researcher in the field for 30 years of experience spanning natural products, green chemistry, and nanotechnology. He earned his PhD from Mysore University in 1998, specializing in chemistry of cashew nuts shell liquid. His early career included significant postdoctoral research at University of Western Cape and Rhodes University in South Africa. From 2002 to 2007, he had his senior research and scientific lead roles in Germany at the Max Planck Institute and Heidelberg University. After a brief tenure as an assistant professor at MIT Manipal, he spent 8 years of his life as a lead researcher at Tata Chemicals Limited. At Tata, he successfully superheaded technology transfers and developed commercial products in food and agricultural sector. He later served as the chief operating officer at IITB Monash Research Academy, posting excellence in PhD research. His academic outputs include over 30 international publications, 8 book chapters, and 17 Indian and US patents. He is a recognized PhD guide and a member of Board of Studies for Defense Institute of Advanced Technology. Currently, he is serving as the Director of Research at Ayurveda Institute of Education Research. We are deeply honored to hear from you, sir. We welcome your speech.
Hope all of you can hear me. From a world of multiple universe, I think I have to now speak about a small molecule that is present in it. It's a challenge, but as one of the physicists, most notable Feynman said, there's plenty of room at the bottom. There is a lot of fun when you go deeper. So let's go deep dive and then see what is in store for all of us when we talk about rasayanas. I'm going to talk to you about identifying, characterizing, isolating, purifying, and concluding that this is either thumb. This is what we are offering. So when you're as doctors, Ayurveda doctors prescribing, you should be knowing what you are giving. The world is not a good place. I'm not saying with a lot of cynicism, but there are people out there who want to give spurious materials. We did this analysis on Jason, which is one of the most used food material in the Indian context. The dairy samples that we procured from the Bangalore market, some of them are. So I'm not scaring you, but go with the right people for the right reasons so that you have the right results. So I represent Prayoga. I'm here to talk about the kind of work that we are already doing on our journey in the project that we are associated with, the collaborating partners, which is IAC, Samatvam, and Carry Bangalore. I'm one of the collaborating partners here. Why we should be talking about natural products are wide, too difficult for somebody to comprehend how wide nature is and what is the kind of material that we synthesize. You have rasayanas, for example, formulations that you're generating. It involves not just one extract of a material, it uses a concoction of it. There is a procedure that is done to prepare the rasayana. All of them are becoming so relevant now for us to study why certain things work, why certain things don't. I can give a mixture of plants and then say that you eat all of them, you could be doing the job. But rasayanas are prepared in a special way so that the two molecules which are present in two different plant materials come together, have a synergistic effect. That is actually playing a role in the disease healing. So if you are talking about rasayanas, we have not even understood 5% of what our forefathers and rishis have done. That's the conclusion I can draw. Right? But if you look at the plant extracts, there is too much of complexity. The natural mixture, which is a mixture of, we don't know what are the different plant materials that you need to use to create a rasayana. The microbial metabolites. So it poses a lot of challenge in quantifying, qualifying, and actually understanding how they actually interact and form a new entity which may be non-covalent also in certain cases, behave a certain way. For example, curcumin is a molecule that was taken in the previous one of the previous. Curcumin doesn't dissolve in water, but you can make a co-crystal where the solubility can be enhanced, where the bioavailability therefore can be enhanced 200 times. These things are live examples for us to understand how materials behave differently under different conditions. That's the reason why the whole of material science is a science today to study how things happen. And if I have to extend it, if I give the same ingredients and then ask all of you to prepare rasam, I'm sure that none of the two rasams will be identical, though you have used the same ingredients. Right? So now I am under the impression that you have understood some amount of complexity exists when you have to do the characterization. Right? Today, the body which governs and then sells the Ayurvedic preparations have kept a certain standard protocols. Just here to tell you that there is a lot of opportunity for each one of you to participate and improve that. This is my submission. These complex matrices contains both primary and secondary metabolites, which are very complex in nature. I'm just going to open up the kind of molecular weight or the polarity or the size, the nature, the functionalities that they possess. All those things play an important role and a wide diversity of connections that can happen between molecules, leading to newer entities. Successful characterization, therefore, should talk about comprehensive identification, isolation, characterization of individual materials that are present in the formulation that you are using. If you look at the nature of the compounds that you have alkaloids, you have terpenes, flavones and flavonoid related materials, polyphenols, xanthones, quinoids, saponins, tannins, the list goes on. But if you look at them, there are 100 different terpenoids present in a particular plant species, maybe connected to a flavonoid. Right? The camphor, pinene, all menthol, all these are the simple terpene molecules. They add a lot of value. You have seen that menthol, when you take pudina, you get the sweetness for the tongue, the throat. That is because of a monoterpene called menthol. Camphor, all of you have heard of camphor. So that is a monoterpene. But if you go to as complex a molecule like a tetranol triterpenoid that is present in neem, for example, neem oil extract contains at least about 100 of them. Azadirachtin is one of the very important ones. Azadirachtin, when I was doing my PhD, was sold, 1 milligram was sold to $60. 1 milligram of that compound. Okay. It is a potent ecdysis, material which kills cycle. It is a potent insecticide material that is perfect nature based, that's set up in class. So similarly, there are so many compounds, we are not even, I don't know how many zeros you have to put, 1% of what nature does as a chemist. One of the techniques to identify some of the secondary metabolites is a technique as simple as a thin layer chromatography. Chromatography as a subject emerged in 1901 by a botanist called Sweat in Warsaw, when he took the sand from the seashore and he could identify the coloration that is present in one of the flowers. 1901. And you have at least about 15 journals which talks exclusively about chromatography. In 1941, Martin and Sinch came up with GC, gas chromatography, where volatile compounds of a plant or a secondary metabolite from a plant species can be separated on a column which is about 100 meters in length, thin column on which it separates. Today, all the 288. So you just imagine how they were created, or whom they were, invented in the first place, and what is the trajectory is used called HPDLC, high performance thin layer chromatography. This is the one which you get with your sample certificate of analysis, that you had a spurious sample which doesn't get detected using this technology, you will not be able. Okay, so there is still scope for improving. Apart from that, the chromatography actually extends. One of the primary things that they do is to use AHPLC that you have. UV, if it is non-volatile, you cannot use GC. Or you have to convert a molecule which is non-volatile into a molecule that becomes volatile, and therefore that can pass through the column and then get separated. Supercritical fluid chromatography became extremely important in heat sensitive materials, thermolabile materials which undergo degradation in heat, pH, pressure. Therefore, when you put carbon dioxide in that, it becomes a liquid, and then it becomes like a differing polarity solvent. So you can extract plant materials, select materials, and it has its own limitations. This is between the two pictures. So this is how it looks. So there is only one which is differing in both these. Both of them contain 6 plant extracts. One contains 5, or 5 of them are common, 2 of them are differing in each one. Okay, so this is the GCMM. Can you see on a TLC plate or a HPPLC plate? Can you see on a TLC plate or a HPPLC plate, you will get only 2 spots. In order to isolate, now you have found that there are 50 compounds, and you make fractions, and then you check for which one is biologically active. That's active. Now what you do is you use something called preparative HPLC. Preparative HPLC using a flash is to make it fast, but you use about a gram of the sample and you isolate. So that is the depth that you can go with the advent of the new instrumentation. This is one of the examples. Flash chromatography, you can see that activity of these molecules are active. Once you isolate, you need to characterize whether it is the same molecule, the UV, the vacuum UV, and then the visible, and then the IR, or the radio waves. You use that. The positivity actually gives the wavelength, which is conveniently converted into the conjugation or the functional group that are present in the molecule. IR, which is a vibrational spectroscopy, talks exclusively vicinity, and therefore they can give you the structure. If a sample has an unknown structure, you want to become a to find out what is the molecule made of. So you use NMR for giving the structure. An unknown compound, you can actually be a detective to use all these techniques to arrive at a new molecule that is being identified from a plant, say that this is this molecule. Right? Example, if you look at this UV, the same 2 samples for which I sent you the GCMS, it shows somewhat a small peak here, but it has a big peak at 280 and the one at 220. 220 is generally for all types of molecules, for example, carbohydrates, proteins, everything of that. But 280 is typical of a secondary metabolite, which is more like your phenolics and things like that. So this is the wavelength that you would use in a HPLC. It gives information to you on what is the wavelength at which you need to observe the compounds that are present in this particular formulation. IR gives you a lot of information. Actually, if I look at this molecule, I can be very sure that there is a lot of OH group, small number of CH stretching, which is like this particular 2200, 2850 and 2900. 1600 is CC double bond, 1400 is CH bending, CO stretching vibration at 1040. You can easily, somebody who has spent a lot of time in these kind of analysis can easily find out as well as related about the first club. So you can talk about the molecule and the nature of bonds that are present in this molecule very readily. The one which is now making a lot of noise, and I think there will be a lecture on this in the afternoon, is to use mass spectroscopy for high-end quantification and qualification of molecules. This is not just restricted to secondary metabolites. The primary metabolites like your nucleotides, proteins, proteomics, genomics, all those things are being done using high-end mass spectra. And these are the kind of instruments. This instrument is presently at Prayoga now. We are using this extensively for the project. These are the high-end mass spectral and advanced NMR is another powerful tool to give the through space interaction. For example, when the protein folds, you can actually check which amino acid is coming closer in space, not bound, in space because of the folding that has happened. And that can be told by nuclear overall. There are some non-destructive methods, Raman spectroscopy, for example, where you can use a camera to identify a particular particle in the sample, and then you say what is it made of, and through the vibration spectroscopy, interpreting it can give you broadband. Likewise, the near IR can also give broadband. And XRD is something which probably we would be making breaking news in the next month or so. A lot of Ayurveda samples have gone through our XRD, and we are finding some exciting results, and it should be a news very soon. So if you look at the integrated analytical flow that you have for any samples that you want to analyze to the precision of the last molecule that is present in these samples, you have to extract it from the plant material and then fractionate it, make them into fractions, do the profiling, and then see what kind of materials that are present, purify and isolate individual compounds, and use the structural elucidation using all the spectral and future direction with large amount of data that is coming. For example, if I take 10 different Ayush samples of a particular Triphala, 10 different make, if I isolate and characterize all these things using all of these techniques and keep a repository, then the moment any sample is analyzed, AI should be able to tell you that this is the percentage of this particular of the Triphalas that are present in the sample. So that is the kind of data that we will be generating, and that AI-assisted technologies will provide you that kind of an information. Microsampling. When you have only 10 milligrams, for example, vitamin B12, the structure of B12 was given with 500 microgram of the sample. That is the amount of the sample people had in 1950s. But you have the flexibility to use only few microliters of the sample to characterize in totality of the molecule using techniques like capillary NMR and nanoanalysis. These are the things which will now bring in a lot of help for the researchers in this area to utilize and then come up with permanent solutions. And I thank you. Finally, with all the information that I put through, this is the instrumentation room that we have at Prayoga. This is Prayoga Institute of Education Research in the outskirts of So if you are really passionate about utilizing an opportunity to get a hands-on experience on the kind of materials that you need to characterize, please use the opportunity. Let us create an opportunity for people to see. It will be a workshop mode where you will bring your samples, Ayush samples that you want to characterize, use all the techniques yourself after being taught, and then see how best you can learn and understand the beauty of how things work.
Thank you, sir. Thank you for enlightening us
Any
with
questions?
advanced technology. Anybody has any questions?
Don't ask me when is it happening. Yeah, we can curate that. That's not a problem.
I hope there are no questions from the audience. I would like to request Dr. Sulochana ma'am to felicitate. Dr. Swaminathan sir and Sulochana ma'am to felicitate Dr. Nagaraj sir.
Thank you.
Without further delay, we will move on to our next technical session. This is from Dr. Ansani Parunti. I would like to introduce her. She is currently working as a National Postdoc Fellow at Indian Institute of Science, developing sensors for kidney disease monitoring in collaboration with AIIMS Delhi. She earned PhD in Material Science and Engineering from IIT Gandhinagar in 2021, specializing in nanotoxicity and biomaterials. During her doctoral studies, she was visiting scholar at University of Colorado Anschutz Medical Campus under fully funded fellowship. Her academic foundation began with B.Tech in Biomedical Engineering from IIT Bangalore. She graduated as a gold medalist. Professionally, she has designed point-of-care electrochemical sensors for detecting uric acid and total cholesterol. She also serves as a biosensor safety lab in charge at IISc, mentoring PhD scholars and training interns. Her research excellence is recognized by prestigious awards, including DST ANRF National Postdoc Fellowship and multiple international travel grants. Technical expertise spans advanced nanomaterial synthesis, physicochemical characterization, and molecular biology techniques like RT-PCR. Beyond the lab, she also has a strong record of community service, including volunteering at Make a Difference and Youth Red Cross. She has published many papers and book chapters. Currently, she is a participant in 2026 Nucleate India Bioventure Training Program, focusing on intersection of science and entrepreneurship. I'd like to welcome you, ma'am, to the session.
Thank you so much for the kind introduction. I hope I'll be able to do justice because there are three challenging things in front of me. A, we had an excellent lineup. Thinking Swaminathan sir's lecture, I was like in some sort of meditative mode myself. So I hope I'm able to do justice to that. I've never got a metabolic syndrome explanation like that ever through all the little bit of experience that I had. In addition, I'm holding you up for lunch, so I apologize for it, but I hope I'm able to do justice. Okay, thank you so much for the invitation, ma'am. I'm Anjani, and I'm currently a national fellow here at the Indian Institute of Science. I'm a trained material scientist, so I want to really marry this whole concept of doing Ayurveda and material science together. And I'll try my best to find that intersection for each one in the room today. So I'm going to start with metabolic syndrome. Swaminathan sir mentioned about how great things can be. I think I'm going to highlight what can go wrong. Okay, so I'm going to start with that. So in recent times, so some of the recent studies that we have been learning about talks about diversity. It's no more. We don't isolate obesity and diabetes as such, but it is sort of the same, everything is in the same basket over here. So it starts with our lifestyle choices that we make. Of course, there are certain genetic predispositions that we also have. However, what happens is this leads to, at a molecular level, it leads to inactivation of certain critical enzymes that leads to generation of reactive oxygen species. So reactive oxygen species is very important, and a lot of Ayurvedic agents that we take are antioxidant in nature. And say it has got high antioxidant property, and what we're trying to do is trying to strike a balance between the generation of reactive oxygen species, mitigate that, and elevate some wherever it is necessary. So cell death, reactive oxygen is very critical. We don't want certain cells to live in our body. So that homeostasis is something that we're trying to strike. what it leads to is insulin resistance eventually. And there are two kinds of things that can happen in the body: either insulin resistance through this particular pathway, and another one is insulin deficiency. Both the conditions will lead to one single metabolic syndrome. That's called PAC. We're getting a complete package together. And it is also correlated with cardiovascular diseases, chronic kidney diseases, and so on. The list is long. So, what is the aftermath? What I want this audience to really focus upon is essentially these kind of biomarkers that get generated. Essentially, they are cytokines in our body, because of which we get to understand that yes, something is going wrong. The point is, can we detect that early? That is the first thing. Is the therapy that we are trying to design? We are talking about Ayurveda today. So, the Ayurvedic line of treatment that we are trying to give, are we trying to, curb these kind of inflammatory cytokines which are getting generated in our body? Are we trying to do it early? Are we at the right time and spot? So, essentially, on and on, there are a lot of markers. So, basically, body shows us a lot of signs. We got to catch these markers, that's our job. And there are various ways of doing it. Today, my talk is about how nano can truly help us, because I'm a trained nanotechnologist, so I can only talk about nano. I don't think I have expertise in anything else. So, how can nano really help us, both in terms of therapy design as well as in terms of diagnostics? What I'm trying to do today is take you through various case studies of what has been already existing, some of what we also do. At the same time, where can you be of great value and maybe help us win a Nobel Prize, as Professor Navkan said in the morning. Yeah. So if we look at the therapy landscape in general in metabolic syndrome, it is categorized in 4 stages, and it is categorized by various kind of signs and symptoms that you see in a patient. Whether it is your waist circumference, your BP, your glucose levels, your cholesterol levels, and so on and so forth. Until basically your patient reaches the last stage, which has developed CVD, CKD, PCOS, and so on and so forth, there are various interventional ways even at the previous steps. However, in the current line of treatment stages, we try to have certain levels of glycemic control through various formulations that is being given to us. Now, the challenge is when you give an oral administration, there is no targeted delivery. That is a very big challenge for all of us, because those molecules are not stable in the GI tract. Imagine it starts with, so GI tract starts with your mouth, goes through your esophagus and to your stomach. The pH variation can be anywhere between 7 to 2. So a molecule, a specific material, may not be stable at pH of 2 versus pH of 7. And that becomes a very big challenge. So we need certain carriers, especially design carriers, to deliver this at the right spot at the right time. That's the first thing that we need to do. Second problem identification is for patients who need insulin administration, people who are on continuous insulin support, and very critical diabetic patients. For them, usually there's a lot of patient discomfort because you have to keep monitoring again and again and put them on therapy. But at the same time, there is prolonged long-term toxicity of these dosages, whether it is allopathic or Ayurvedic. Eventually, over the period of time, if we don't characterize or if we do not do a targeted delivery, it can lead to toxicities. So, where nano helps us? First, we are able to build up nanodiagnostic systems where at a very miniaturized level with minimum sample volume, you are able to assess what the real problem is. You are able to catch that metabolite at an early stage. That's the first thing we do. The second thing we do is actually develop a therapy system which is physicochemically stable and is bioavailable, which is very specific to the site that you want to target. And the third is essentially, which is getting very famous now, which is a nanolipid system. Take it, as a small nano cholesterol bodies that you're trying to package your drug in and just shoot it in. So we say that, okay, cholesterol is your enemy. Actually not. Sometimes not. These lipid molecules are nothing. We are trying to create a perfect marriage of hydrophobic and hydrophilic, moieties coming together, encapsulating your drug, shoot it, and that gets flushed out of the system, provided we are able to regulate it at a very minuscule level. So, the first part of my presentation is going to be more about the nanotherapy, which has been ongoing. And the second part of my presentation is going to be on these kind of diagnostic tools that have been brought about. So, since Sulochana was very specific about metabolic disorder, and diabetes management is one of the most important aspects of it, I'm going to focus on how these nanocarriers essentially help in glucose regulation. So there's something called as a nanozyme. So nanozyme is nothing but a single nanomaterial which will behave like an enzyme. So physicochemical property of that particular material, we tweak it to the level that it starts behaving like an enzyme in your body. And that is absolutely possible. Now what it does is, it essentially tends to reduce ROS at a lot of levels. It can also be counterproductive sometimes if it is not engineered properly. But the target that we want is essentially to reduce the reactive oxygen species at a cellular level, so that we are targeting the disease at the cellular level, and we are not sending out a drug which is going to act everywhere in the body. So what these nanozymes do is essentially go on the metabolic pathway, and they try to target a specific protein that you want to knock off completely. And so the dysregulation turns into regulation now. The other example that I want to give you is of insulin delivery. So now we are also seeing technologies where we are able to targetedly deliver insulin in the body in various formats. Why I have taken this specific example is, you see this entire borophenol group. It's basically a phenol boric acid group. Okay. It tends to detect glucose. But what is the problem? It's non-specific. This is a compound which is very commonly found in Ayurvedic extracts. The problem is that it's not specific. Now, how do we make that specific? What researchers have done essentially is they have functionalized it. So sometimes slight post-processing of an extract material can bring specificity. And because of that specificity, what happens is, it tends to bombard the whole carrier that you're trying to carry. And the moment you see this change, your body sees this change, it bursts open and releases your insulin at the targeted site that you need. Now, what did people do over here? What they try to do is essentially encapsulated glucose oxidase on top of these kind of carriers or extracts. What it did was, the moment your carrier detected that, the surface of your carrier essentially detected that, okay, I have found glucose. Glucose oxidase reacts, forms gluconic acid, the pH drops. The moment the pH drops, suddenly there's a burst release of that particular drug. So your drug or your insulin is not getting released all across the body, but it is getting released where it is needed. Sometimes, this kind of therapy actually started from cancer treatment, and now it is implemented in a lot of other diseases. And it's very important that we are able to curate this at a level. Now I would like to talk about, this is one of the case studies about diabetic wound management. So this is a typical theranostic application. Theranostic application because you are able to sense it. So essentially it's a hydrogel. It's something like, the commonest example I can think of is an aloe vera gel. It has so much into it, right? And you can also pump a lot of things and make a very comprehensive gel out of it. This is what we make in the labs, actually. So we are trying to encapsulate silver nanoparticles in these kind of gels. Now, what does silver do? Any guesses? Silver? It's very primitive. Yes. Absolutely. It's antimicrobial. So what it does is, it delivers silver at a very slow rate, and it is able to do dual function. We are able to sense it because of pH responsiveness. At the same time, the moment we feel, okay, the wound is getting worse. And why? Because there are biochemical cues which are at your wound site. And we are designing those carriers to catch that biochemical cue and create a response to it. And the response is release of silver ion. And this is how you treat diabetic wound. There are a lot of examples that have been existing in our literature. It ranges from metal to metal oxides, to polymers, to lipids, and the list is long. Even the recent Nobel Prize on metal organic frameworks, that has also been established for wound therapy for that matter. Now, the last case study on therapeutic that I'm going to take is on obesity management. Now, it is not just, as I mentioned at the start, it's a complete package. Obesity and diabetes, it comes together. It's a full-blown package. So, how are people treating over here? And this also put me into a thinking that today we are encapsulating these kind of drugs and genetic markers and sequences. Can we really load Ayurvedic extracts in it and it deliver? Maybe that's where we need to think about. But what we need to truly understand is how these cues essentially contact a specific site which is present in a cell, and how does it molecularly translate into knocking off the markers that we want to knock off. Like for example, in this particular example, I want to focus on it is essentially again a self-assembled microneedle that people have created. It is a pure polymer which is cured by UV light. So basically, especially girls can relate to it maybe. When you do nail art and you put your hand under the UV and suddenly everything gets cured. It's the same technology where you are trying to put materials and cure it essentially. Something like creating a nail art and no less than that. So you create microneedles. Now, the moment it touches your visceral fat area, it tends to release or degrade or disintegrate. What is it carrying? So these oligopeptoplexes carry these genetic sequences. Why is it important? It binds the specific site which is prohibited, and it is used to knock off that FABP5 and FABP4 mRNA. So we need to understand at a molecular level how these agents, whether it is a genetic sequence that you're trying to send, or whether it is a particular small molecule that you're trying to design, has got an after effect on the follow-up knocking off of a particular marker that you're trying to target, essentially. So you are cutting the problem of lipid accumulation in the body in one place. So essentially now you will have no more fat accumulation if you knock off these two markers. So can we achieve that with any Ayurvedic extract that we can package in these kind of oligopolyplexes and just shoot it into the visceral fat? I think we can do that because nanocarriers we can design for you, but I think you have to give us the information about those extracts that can target that FABP5 and FABP4. Yeah. Another example is of phototherapy. So even Swaminathan sir very beautifully focused on phototherapy. So we say that, oh, let's not get tanned to go in sunlight, right? It's not about getting tanned, but it's actually, it generates something called as exhaust. So this is a plant extract. And these exhausts are extracted when a light shines on it. Now what we're trying to do is extract it, condense it, concentrate it, shoot it in a mice model. So this is a study which is being conducted. And it is published in Phytomedicine. Guess what? It's been done by Chinese medicine guys. So we need to catch up. So what happens is they kind of shine light, and what it does is, again, it regulates the reactive oxygen species. But over here, you're trying to increase the reactive oxygen species so that you cut down on the adipocyte, which is undesirable. So this is how you kill cancer, and this is how you essentially kill fat, by increasing the reactive oxygen species. But you need extracts for that. Now, coming to the nanodiagnostic part for metabolic health management and what is being done already. I'm going to touch upon a very, very interesting patent, which is coming from the University of North Carolina. And it basically talks about self-assembly again, a model that I have already discussed. So you see there are the hydrophilic ends and hydrophobic ends. So even in Ayurvedic extracts, you have certain extracts that are hydrophilic by nature and hydrophobic by nature. What you're trying to do is package them together in the right solvent mixture. And what they tried to do is they waited for glucose to come and attack the surface of it. What did glucose do? It caused reduction on the surface. So So these were the two compounds. These were the imidazole compounds. They are basically responsive to hypoxic environment. Hypoxic is lack of oxygen. So what happens when your glucose reacts with the enzyme? It forms gluconic acid, at the same time hydrogen peroxide. But there is a huge rush of H plus ions at the surface when this reaction takes place. What they try to tap was the increase in H plus ions actually caused a hypoxic environment in that particular micro area or a nano area. And eventually there was a burst release. So what they tried to do was sense it, which is that area which is hypoglycemic. Are we in a hypoglycemic zone or are we in a hyperglycemic zone? So when a patient is hypoglycemic, you need to, it needs sugar in the body. Hyperglycemic, you need more insulin. So that insulin which was packaged in the carrier only got released when there was excess of glucose present. And so this is how it was sensing and treatment at the same time going on with just a small moiety, which is maybe 5 nanometers or 10 nanometers. So this is how we can tap into the potential of nanotechnology. Giving another case study which we have been working on for some time. This is the data which is coming out of our lab. And we have created these nanostructures, which are essentially copper oxide nanostructures. What we've tried to do is dope it. Now you would be like, this is one of the sample I have put up over here. You'll be like, oh, why are you doping it? Maybe you want to use it just like that. But even for example, copper is a micronutrient. I don't think anybody knows it better than Ayurvedic community. It is a beautiful, beautiful agent. But if it is within the permissible limit, the moment it crosses the permissible limit, it becomes toxic. Now, how do we control that when we are engineering these materials? It's essentially by doping. This is naturally present in natural extracts. So what you see as copper is not completely copper, they're copper complexes. Sometimes they're bound too tight and they don't release, but in some cases they just release, and when they release, they cause toxicity. That's the point of it. So we try to dope it. And you can see one interesting thing that we were trying to detect glucose. And with changing the percentages of other transition elements, we kind of maximize the sensing currents over here. So that's the beauty of materials. I won't go into the mechanistic details, it's beyond the purview of the presentation. But this is, and eventually we can also see how the sensitivity and the limit of detection of these sensors also change very dramatically. So we want a very low limit of detection. So we were able to achieve somewhere around 15 to 18 mg per deciliter. Humanly not possible. If a human goes there, human won't be there. But a very high sensitivity at the same time. That means even a small change in the glucose concentration in the blood will be picked up by the sensor very quick. What we try to do is we picked up the best variant and we say, okay, let's work on making a continuous glucose monitor out of it. And we do it indigenous. And so we tried it with different concentrations over the period of 120 minutes. Rather, we went up to 7 days also. And we were able to prove that we are very effectively tracking the glucose levels, even at this small a fluctuation time range. We are able to do that. Now, when we look at the sensitivity of these sensors, these are all nano sensors, as small as 1 mm cross 1 mm. The sample volume would be 6 microliters, not more than that. It's as small as 6 microliters. So, no patient discomfort in that sense. We could see that in simulated interstitial fluid also, we maintained the sensitivity of the sensor was maintained. Another case study that I would like to take you through is of kidney function management. We tried to design this sensor out of a nanocomposite material. It's a very classic material which is getting very famous after Omar and Yagi got the Nobel Prize for the metal organic frameworks, because this entire study was based on metal organic frameworks. We designed nano metal organic frameworks, they're sheet-like architectures, and we kind of immobilized gold and silicon on top of it. And what we did was we immobilized, again, chemically cross-linked the enzyme, sorry, not the enzyme, the antibody on top of these nanostructures. Now, what we were expecting is that the patient sample that comes to us would be having an NGAL, because the patient population was very restricted. This work was done in collaboration with AIIMS Delhi. So we knew that this set of patient population will have neutrophil gelatinase hypocalin family of protein. This protein is a very, very sensitive protein that helps in early detection of kidney disease, especially in congenital disorders that we see in children. So what we did was we were expecting this, and NGAL kind of tagged itself to the beautiful anti-NGAL that we had decorated, led to increase of resistance and drop in current. And this is why you see over here that with increasing concentration, your currents are dropping. And we were able to achieve a sensitivity of around 10 to 12.5 nanograms per ml. We can go as low as that. So we kind of make this artificially in the lab, but there have been not just stories. We have actually done organic, green synthesis. So green synthesis is a very common method which we do from standard waste materials like orange peels, like potato peels, and so on and so forth. Something which definitely Ayurveda community should explore. And I will also wrap up with a case study on that. Another kidney function management sensor that we had developed was a very flexible sensor, a very small sensor that can bend easily, so it can go as per the conformity of your skin. You can maybe wear it as a band if you like, eventually, if and when it comes down in the market. So what we do is basically we married this material to the gold, to the sensor. The sensor was a solid platform, but this was a highly mobile platform. And why I'm talking about this particular molecule is, if you can imagine the structure of hemoglobin, what we did was we knocked off the iron and we put nickel here. That's all what we did. So we are learning from nature, we are evolving from nature. So we put nickel instead of iron, we married these two materials, we immobilized it with an enzyme called R-uricase. The moment from the blood sample where uric acid was seen, it converted itself into allantoin and H2O2. So the detection mechanism was basically we are trying to sense this small moiety over here. That's about it. And you see that this is the response we got with human plasma. This study was conducted in collaboration with Samantha. We sourced all the blood samples from there, serum samples from there. So we can see that our sensors kind of overestimated by 3 to 8%. However, compared to the commercial kits that are available, we did well. So good sensitivity and lower detection rates. Another is for cholesterol management. I promise I'm going to finish in another 5 minutes. I know everyone are hungry. So in cholesterol, in natural body, cholesterol does not exist in one form. It exists in two different forms, which is free cholesterol and esterified cholesterol. The ratio is usually 30% of free and 70% of esterified. But these ratios can also change depending on the conditions and lead to the atherosclerotic potential in a patient body. What we did was we created field effect transistors out of it. So now there were no more simple sensors, they were field effect transistors because they offer higher sensitivity. We used MOS2 equivalently linked the enzyme, again with a copper oxide base, and in human samples, these are all studies conducted on human samples. You can see that the data that we had got for 480 mg per deciliter also gave us very good resolution. This is the power of nano. So this talk is more about the power of nano today. So I would like to actually wrap up with a very strong message that do you think nanotechnology as a therapy is recent? I have given the answer. It's not. It's absolutely not. So all the bhasmas that we talk about are nanomaterials. And the point is that they are not very well evidenced. That is the whole thing. Maybe I have made some error. Looks like I'm not the best person in this field, but I don't know much. But when I went through various records of materials that are manufactured in terms of bhasma, if you look at it, they're all nanomaterials. But what decides whether these nanomaterials are potent or non-potent are the physicochemical properties of these nanomaterials. What is undocumented at this point of time in Ayurveda is that whether this physicochemical property has a certain type of potency or not. That corroboration or that correlation is something which is missing. So we need to characterize this very strongly, not just microscopically, spectroscopically, but holistically, even in terms of electronic band structure for that matter. We need to come up with a recipe book that we have in material science, no recipe book for bhasmas, that what is the activity correlation with the physicochemical property. This is one of the studies which really intrigued me a lot. It's essentially nothing but zinc oxide nanoparticles. If you look at it compositionally, you change so over the period of these cycles, what they did is they changed the temperature and nothing else. The temperature basically caused a crystallographic change in this material and made it more bioavailable and more bioactive. So the way you are treating your bhasma essentially is like we treat our material and we do phase transitions. In material science, we call phase transitions. So are we phase transitioning the material? What is happening? What kind of crystallographic orientation is getting changed? We need to find this out. This study was conducted at the Ayurvedic Drug Discovery Institute in Haridwar. So very interesting study again. What I would like to leave you with the last message is, are nanomaterials safe? There's a big word of caution. Are they really safe? What is that territory that we are venturing into? We are progressing very strongly in the field of nanomaterials, but we also need to strongly see and regulate this field very strongly. Regulation is important because depending on the solubility of your nanomaterial, it decides what is the fate of your material in your body. Same as a drug. So there we have pharmacokinetic potentials or pharmacokinetic studies. We also have nano-availability studies. So are we doing that right? Is it ethical? Again, something that man really focused on. Is we need to do in the field of nanomaterials, especially bhasmas that we are talking about. What is the fate of these bhasmas eventually? Whether it is accumulating, it is undergoing exocytosis, it is going into a metabolic pathway and treating a particular disease, or whether it is causing cytotoxicity or genotoxicity. And the answer lies in primitive material science. The primitive material science is, what is the hydration enthalpy of the bhasma? What are the dissolution characteristics of your bhasma? What are the electronic properties of your bhasma? At the same time, how do they really interact with certain receptors which are present at a molecular level on the surface? There are some really big unanswered questions that we have to answer, and they're pressing ones. So with this, I would like to send a warm acknowledgement to first of all Kari and everybody who thought that I may add some value to this workshop, given this lineup is super prestigious. At the same time, my postdoctoral advisor, Professor Bharat, our clinical collaborators and clinical partners who have been working with us for very, very diligently. I think we could not have done any of this without them. So thanks to Department of Pediatric Surgery in Delhi and Samartham Endocrinology Department. Our NNFC, the National Nanofabrication Center, where we build all these sensors, the micro nano characterization facility where we characterize them, all the funding bodies who have funded us, and our entire group. I think had I not have the support of my excellent interns and PhD students who worked alongside, these studies would not have been possible. Thank you. I'm happy to take any questions.
There will be an issue of selectivity, I think, nano technology.
Okay.
Studies using nanotechnology and campus.
I have not presented it over here. Ferrites are something which have a very potent carriers. So something that you also extract out of orange peel. So the example that I quoted for orange peel specifically is because the yield of ferrite materials are very high. in that sense, provided you cure it at the right temperature in the right condition. It has been seen that steroids are very strong carriers for anti-cancer drugs, well, not like cisplatin and things like that, but certain very targeted drugs because cancer microenvironment is usually low in pH. So the moment you have a cancer cell and a normal cell, the difference is pH. pH is lower for the cancer cell microenvironment versus the normal microenvironment. So you can definitely design a ferrite-based carrier out of these orange peels, very humble orange peels, make them pH responsive, load your drug within that extract of the orange peel that you get, make it pH sensitive and target. So it is absolutely possible. Done some preliminary. I won't really comment much since we have not seen it.
Very nice presentation, Dr. Ajay. Have you done studies on in vivo whole animals using nanotech drug delivery?
To the toxicity aspect and vigilance aspect. Things get pretty complex because we tried to test out a few copper oxide based materials in mice models. But the response was very shocking. The shooting up of IL-6 and TNF alpha was so high. Even when we had tried to regulate the amount of copper release, we've seen that there is huge influx of cytokines coming in within in vivo models. So we could assess that those materials are failing. So we did not see a point of proceeding with this. But copper we consider as a micronutrient actually gave us a lot of shock in a certain way. That even at nanograms and picogram level at an organ scale, it was giving a very high IL-6 and things. So it did move into the regime of toxin.
For the question during the lunch or reserve for wrap.
Absolutely. Thank you.
Thank you, Doctor. I would like to request Dr. Sulochana ma'am and Dr. Pratibha Nadi ma'am to state Dr. Ajay Pariti.
I'm going to make zip outside out of that.
Thank you. Thank you everybody for your patient listening. Now we'll have lunch break. We may all get back here by 2:30 so that we can start our technical session on time. Try to be faster. Thank you. will start the afternoon technical session. Now we have our speaker, Dr. Madhumati S. Vaishnav. Dr. Madhumati is a postdoctoral research associate at the Center of Nanoscience and Engineering, IISc Bangalore, specializing in diabetes pathogenesis and therapeutics. Her academic foundation includes an MSc in microbiology and a PG diploma in clinical research from the University of Pune. With over a decade of experience at Samatvam Diabetes Center, she has progressed from a research scholar to a scientist in translational medicine. Her expertise encompasses automated insulin delivery, biosensors, and natural product pharmacotherapy within Ayurvedic sciences. A certified diabetes educator and insulin pump trainer, she actively volunteers for charitable clinics in Isha Dosti. Her work has been recognized with prestigious fellowships and travel awards from International Society of Endocrinology. She has further specialized through laboratory medicine, training in mass spectrometry, and robotic autoanalyzers. Currently, her research focuses on the intersection of proteins, molecular biology, and innovative diabetes care technologies. We welcome you, ma'am, for the session.
So, namaste. Good afternoon, dear all. Shall I start my lecture? Yeah. Okay. So, the topic which Madam gave me for today's presentation is molecular basis of diabetes and related metabolic disorders, modern analytical techniques of mass spectrometry. So, these are the topics of my today's presentation. Focusing on beta cell dysfunction. Now, before understanding the beta cell dysfunction, let us understand the physiology of pancreatic beta cells. Okay? These pancreatic beta cells are very specialized endocrine cells, okay, located in the islets of Langerhans, which has a very primary important function of glucose homeostasis by sensing circulating glucose concentration and sensing insulin accordingly. Okay? This diagram shows glucose-stimulated insulin secretion, and this happens in 3 stages. Now, let us first focus on the stage 1. So, the glucose. Now, we had our lunch, so a lot of glucose is circulating in our blood. So, this glucose enters inside the pancreatic beta cells to the glucose transporter, GLUT2 mainly in case of rodents, and GLUT1 and GLUT2 in case of humans. But inside, and this glucose transport or entry inside the cell depends on the blood glucose concentration. Higher the blood glucose concentration, higher the glucose enters inside the pancreatic beta cells. This once inside the cell, with the help of glucokinase enzymes, it gets autophosphorylated to form glucose 6-phosphate. This is a very important step in glycolysis. Okay, and that's why the glucokinase is also known as the glucose sensor of the pancreatic beta cells. Okay. Inside the cell, this glucose undergoes the metabolism by the glycolysis and mitochondrial oxidation. As a result, there is an increase in ATP concentration. And this is a very important stage. This increased ATP concentration inside the cell activates ATP-dependent potassium channel. This potassium channel is made up of this is 6.2 subunit, which is shown in blue color, and SUR or sulfonyl receptor shown in the red cell. This activated potassium channel gets bind to the KIR 6.2 receptor. As a result of that, okay, there is a membrane depolarization. Means what? These channels get closed. As a result of that, this potassium can't go outside the cell, and there is an increased potassium concentration inside the cell, which gives rise to the membrane depolarization. And this is also the second important event in the glucose sensing. This membrane depolarization further activates the voltage-dependent calcium channel, L-type. As a result, calcium, which is present outside the cell, enters inside the cell. As a result, there is an increase in intracellular calcium concentration, and this calcium directly helps for the insulin secretion. So when inside the beta cells, insulin secretion always happens in two stages. One is a very fast insulin secretion and one is a very sustained slow insulin secretion. Fast insulin secretion happens because there are some pre-docked insulin molecules or granules are already formed. And the second sustained insulin resistance is after the activation of intracellular calcium concentration, these granules start formation and there is a continuous release of the insulin. Now, with this understanding, now let us understand what is the beta cell dysfunction. The beta cell dysfunction is a reduced ability of beta cell to secrete insulin in response to hyperglycemia, and it is a major defect in individuals with type 2 diabetes. See, the chronic hyperglycemia negatively affects the beta cells to the process of glycotoxicity. So what is the glycotoxicity? It is the ability of glucose to accelerate the pancreatic beta cell death. Similarly, the chronically elevated concentration of free fatty acid to the process of lipotoxicity again have the negative effect on pancreatic beta cells. Together result in beta cell dysfunction. Along with hyperglycemia and free fatty acid, even the over-secretion of insulin to compensate for insulin resistance also contribute to beta cell dysfunction. So now this slide shows the role of pancreatic beta cell in the early pathogenesis and progression of type 2 diabetes. Always the genes plays a lot of important role in the type 2 diabetes. This slide shows the factors which are responsible for inadequate insulin production by individual beta cells. And these factors include genetic predisposition, metabolic, endoplasmic reticulum and oxidative stress, mitochondrial dysfunction, impaired insulin processing, beta cell exhaustion, alpha cell dysfunction, microRNA dysfunction, and amyloid formation. Amyloid formation not only happens during the Parkinson's disease, even it happens in the beta cells. Okay, and the factors which are responsible for the reduced beta cells number and size are apoptosis due to glucotoxicity, lipotoxicity, endoplasmic reticulum stress, inflammation, amyloid formation, dysregulated autophagy, defective regeneration. And the factors which are responsible for compromised beta cells identity are beta cell dedifferentiation, abnormal transdifferentiation, and amyloid formation. This is a figure from very landmark study, UKPDS, that is a United Kingdom prospective diabetes trial in type 2 diabetes. This trial shows that the loss of beta cell function occurs almost 10 years before the clinical diagnosis of type 2 diabetes, and by the time person diagnosed with type 2 diabetes, there is already 50% loss of beta cell function. So now with this understanding, we will understand what is insulin resistance. Before that, we will understand the physiology of insulin action. So the insulin carried out is different biological function in different cells, tissue and organs by binding to a receptor known as insulin receptor. And this insulin receptor is a heterotetrameric protein which is located in the plasma membrane of hepatocyte, that is a liver, myocyte, muscles, and adipocyte, adipose tissue. This heterotetrameric protein has 2 alpha extracellular protein units, which are the N-terminal, and membrane spanning beta subunits. This beta subunit has a tyrosine kinase domain, which helps in this tyrosine kinase activity helps the autophosphorylation receptor. And when insulin undergoes the process of autophosphorylation, then only it gets activated. Now, understand the proximal insulin signaling. So once insulin binds to the insulin receptor, through the process of autophosphorylation, different molecular pathways get activated. The 2 major pathways for proximal insulin signaling are mitogenic signaling pathway and metabolic signaling pathway. And both these pathways have the positive feedback mechanism shown in the green color, and negative feedback mechanism shown in the red color. Now we will see how insulin activity happens in skeletal muscle insulin signaling. So this the skeletal muscle insulin signaling has two major functions. First is glucose uptake and glycogen storage. So what happens once insulin activates the insulin receptor? This activated insulin receptor sends lot of signals. As a result, this GLUT4, that is a glucose transporter 4, gets docked with a vesicles known as a glycogen storage vesicles. As a result of this, these glycogen storage vesicles from the cytosol, it gets translocated to the cell membrane, and then glucose enter inside the cell. Once inside the cell, this glucose undergo the process of glycolysis to form glucose 6-phosphate, and this glucose 6-phosphate through positive feedback mechanisms activate glycogen synthase enzymes, and negative feedback mechanism separate the glycogen phosphorylase enzyme, and the net result of increase in glycogen synthesis, that is it stores the food in the form of glycogen. Now coming to the hepatic insulin signaling, okay, and these are the so much molecular pathway, but when we focus on the hepatic insulin signaling, AKT pathway, also known as a protein kinase B, this pathway has a central role, and hepatic insulin signaling happens in two ways. It has a fast effect, that is the activation of glycogen and protein synthetic machinery, and slower pathway, that is a slower transcriptionally mediated effects, where there is a upregulation of glucokinase, suppression of gluconeogenesis, and activation of de novo lipogenic activity. Coming to insulin action in the white adipose tissue, okay, and the critical physiological function is here suppression of lipolysis and stimulation of glucose uptake, again by translocation of this GLUT4 containing storage vesicle to the cell membrane. Now, very interesting, adipocyte-hepatocyte axis. In the fasting condition, in the absence of the nutrition, okay, this now first focus on the white adipose tissue. When there is no nutrition is available in the cell, this adipose tissue does not get activated by the insulin, and this insulin remains suppressed. As a result, this white adipose tissue activates the lipolysis and secretes non-esterified fatty acids. These non-esterified fatty acids, they enter into the circulation, and through the circulation it enters the hepatic cell. In the hepatic cells, these non-esterified fatty acids enter into the mitochondrial oxidative system, where it gets activated to acetyl-CoA. This activation of acetyl-CoA gives positive signal to pyruvate carboxylase, okay, and this pyruvate carboxylase increases the activity of gluconeogenesis. So this is the adipocyte-hepatocyte axis. Now itself, the hepatocytes also has insulin receptors, okay, in the absence of the nutrition, okay, this is inactive receptor. So as a result, the liver increases the process of glucogenolysis, that is the lysis of glycogens, and stimulates the process of glycogenolysis and suppresses the process of glycogen synthesis, and the net result is increased hepatic glucose production. Now, in the fed state, that is after lunch or after breakfast, whatever, when the lot of nutrition is available, so what happens in the fed state, when in the presence of adequate nutrition, this insulin receptors gets activated, and once this gets activated, it suppresses the process of lipolysis. Because of that, non-esterified fatty acids, they are not enter into the circulation. So there is a suppression of pyruvate carboxylase activity. Also, so there is a suppression of gluconeogenesis, that is a new glucose molecule doesn't form. When in the presence of nutrition, direct insulin receptors which are present on the hepatic cells, they activates this insulin receptor, and through this activation, there is a decrease in the glycogenolysis and increase in glycogen synthesis. And net effect of this activity is reduced hepatic glucose production. With this, now we will understand what is insulin resistance. So, insulin resistance is characterized by the reduced biological response to given level of insulin, and it is a state in which normal amount of insulin produces subnormal response. So, because of this insulin resistance, so what are the effects of insulin resistance at the molecular level, at the cellular level? This insulin resistance affects the reduced glucose uptake by adipose tissue, reduced glucose uptake by muscle, and increased glucose output by liver. And the combined effect of all these insulin resistance at the molecular, cellular, and organ level is increased hyperglycemia, that is increased glucose concentration. Just now I showed you this slide, very insulin, this means skeletal muscle insulin sensitivity. When skeletal muscle are insulin sensitive, the process, there is a, the process of glucose uptake is very fast, but in case of insulin resistance in the skeletal muscle, there is no appropriate activation of glucose receptor. As a result, this is in the absence of the inappropriate tyrosine kinase activity, this GLUT4 receptor doesn't get expressed on the cell membrane, and there is a decrease in the glucose uptake. As a result, the net result is decrease in glycogen synthesis. Oh, this is a very interesting slide. Now, hepatic insulin resistance or non-alcoholic fatty liver disease. So, what happens when there is a insulin resistance? Then there is not complete 100% activation of insulin receptor. As a result, the process of lipolysis get halfly activated, halfly suppressed. So there is a incomplete formation of non-specified fatty acids. These fatty acids enter in the hepatic cells, and instead of activating the glucokinase, it increases the intracellular triglyceride level. Okay, so there is an increase in triglycerides inside the hepatic cells. Okay, now when the tissue, when coming to the hepatic glucose signaling, in the case of insulin resistance, though the adequate nutrients are available, they doesn't get properly enter inside the hepatic cells, and as a result, there is a suppression in the de novo lipogenesis and increase in hepatic triglyceride concentration. With this understanding, I am going to explain you ectopic liquid hypothesis of liver and muscle insulin resistance with the help of these 6 phenotypes. Okay. Now kindly focus these phenotypes based on the lipid storage. The first phenotype, lean, insulin sensitive, healthy phenotype. The second phenotype is a lean but insulin resistance, where there is accumulation of the lipid in the hepatic cell and the muscles. As a result, it causes the insulin resistance. And this phenotype is known as normal weight obesity. Normal, they are having normal weight, but they are obese because of the insulin resistance. Now, kindly focus on this phenotype, the third phenotype. They are obese, and there is a lot of adipose tissue deposition in the subcutaneous, lot of lipid storage in the liver, in the muscle. So they are obese and insulin resistance, metabolically unhealthy. Now focusing on this interesting phenotype 4, obese but insulin sensitive. Okay, these obese people doesn't have lipid storage in the liver and the muscle. All the lipids are stored in the adipose tissue and subcutaneous tissue. And these people are, though they are obese, they are insulin sensitive. So what this, the central organization principle says, the lipid storage in the white adipose tissue, especially in subcutaneous depots, is physiologically appropriate. But the lipid storage in the liver and skeletal muscles is inappropriate and it is a metabolically harmful. This ectopic lipid hypothesis gives rise to the phenomenon of normal weight obesity. Now, with this understanding, if we will focus on this last phenotype, this person is very lean but highly insulin resistance. This is a very rare genetic disorder known as a lipodystrophy. These people, they are very, very lean, but their insulin requirement per day is very high because of 100% ectopic fat deposition in the liver and the muscles. And if you want to treat this patient to become insulin sensitive, only leptin therapy is available. Now with this, with these two diagrams, I want to explain the normal weight obesity and metabolically healthy phenomena in a more detailed way. Now kindly focus this right part of this diagram. Okay, this diagram shows the DEXA scan of two individuals. They are obese with a BMI of 31.7. But if you will compare this person compared to this extreme left, this person has a half fat in his body. Okay, so this person is known as a metabolically healthy obesity. This you can only do based on the DEXA scan. And if you will focus on these two research scientists, okay, they are lean. Okay, the BMI is 22.3. But the gentleman, okay, here has the only percent body fat concentration of 9.1%, and the gentleman here has a body fat composition is 21.2%. And identical BMI, body fat gross difference. He is having 9.1, he is having 21.2, and this indicates the normal weight obesity. Okay, so with this understanding, we know that insulin resistance and beta cell dysfunction are the core defects of type 2 diabetes, both genetically and environmentally determined. Okay, so apart from this insulin resistance and the beta cell dysfunction, there are so many defects which present in type 2 diabetes, because type 2 diabetes is a very heterogeneous disease. Okay, and which are the other organs which gets affected, and which this includes defects at the alpha cells, pancreatic alpha cells, defects in the kidney, pancreatic amyloid, brain defects, gastrointestinal tract defects, inflammation defects, immune function defects, and defect at the stomach or small intestine or both. Okay, so this insulin resistance, okay, it is linked to the range of cardiovascular risk factor, which known as metabolic syndrome or insulin resistance syndrome, which include hyperglycemia, dyslipidemia, hypertension, damage to blood vessels, clotting abnormalities, and inflammation. And all these metabolic syndromes responsible for increased atherosclerosis. That's why insulin resistance is one of the important cause of cardiovascular risk factor. So with this understanding, I wanted to show you, okay, the modern analytical techniques of mass spectrometry, okay, which I am going to cover in detail in our lab visit. But now what happened? Till now, we understand the molecular defects at the cellular organ level, okay. So always the disease doesn't express in the organ levels. First, it gets expressed in the molecular levels. And if you will see which are the main biomolecules of the life, these are proteins, these are the lipids. So proteins being a very important biomolecule, it has a major role in disease prediction. So what is the proteome or proteomics? The proteome refers to the complete set of protein expressed by a cell, tissue, organism, or biological system at a given time under given specific condition. So unlike genome, that is the genes, which are very static in nature, the proteome is very dynamic. It changes in response to development, environment, stress, disease, and cellular signaling. This proteome has a different functional, it has a different vast array of the function, which include catalyze the reaction, it provides structural integrity, it regulates gene expression, it transmits signal, and mediates immune response. The modern proteomics study integrate mass spectrometry, which you are going to see in after this period. So mass spectrometry, bioinformatics, system biology, and quantitative analysis to identify, quantify, and characterize proteins, including their post-translation modification, ionization, and interaction. Okay, and the concept of the proteome is a very old concept. It emerged in mid-90s, and it has from that time it's since evolved into the central pillar of molecular biology and precision medicine. So why we need mass spectrometry? Okay, this early proteomics alteration must be investigated at the level of proteome. Okay, and the disease and cellular dysfunctions are ultimately executed by the proteins and not by the genes alone. So to understand the biological mechanisms, we must measure protein directly, and for this we need mass spectrometry because the mass spectrometry is high resolution, highly sensitive, and quantitative analytical platform. So this principle of mass spectrometry, how it works, I am going to explain you in detail during our lab visit. So where we are having the Bruker instrument, mass spectrometry, and I will show you how you can process the blood sample, the urine sample, any biological sample. It can be urine, it can be the plasma, it can be the serum, which we are using serum, and how that will help us to identify the molecular signature of the disease. Okay. So just before that, I just want to tell you, I will tell you everything in the lab visit. So what I did during my PhD dissertation, I only focus on the albumin molecule. Okay. Why albumin molecule? Albumin molecule is an extracellular, not intracellular. Because it is an extracellular, it also comes in the contact with the glucose and it also gets glycated. You know HbA1c is a gold standard. Like that, albumin also go under the process of glycation and we get glycated albumin. And this glycated albumin can be the biomarker, early detection of diabetes, because the half-life of albumin is 1 month. So if you will study the pattern of the glycation of albumin, you can predict the disease at the earliest level. Because of the paucity of time, I am unable to show all the results which are important from my study, but I will just show the very interesting thing. Okay. During my PhD, when I studied type 2 diabetes and type 1 diabetes using mass spectra, these are the mass spectra, the signature of albumin molecule under the mass spectra. What we observe, see, if you will see these two type 2 diabetes, A1C 15.6, type 1 diabetes, A1C 7.1. So glucotoxicity is almost same. But at the high glucotoxicity level, type 2 diabetes had a very high oxidation. This fix shows the oxidative stress. Okay, compared to type 1 diabetes. Type 1 diabetes only showed the major glycation fix and less oxidative fix. So if you know, in type 1 diabetes, there is a complete absence of insulin. Body doesn't secrete insulin. Okay, so we concluded with so many different studies that insulin resistance is one of the culprits in type 2 diabetes, and it increases metabolic glycation and oxidative stress. So the time I can't show you, but we came to the conclusion that, okay, this I will show one more thing. Okay, so we studied patients longitudinally. Okay, when we recruited them, see, we selected patients with a very uncontrolled diabetes. If we will set day 0, okay, this patient has the glycated albumin of 60. And okay, and this patient, when we recruited, he was drug naive. He was not taking any medication. So on the day 0, we started him metformin. As a result, you will say the glycation which was 60, it immediately came within a month. It came to the 30%. Okay, and we continuous decrease in the glycation. Okay, on the day 14, we added gliptin. Because of the gliptin add-on, there is a further decrease in the glycation pattern. Okay, but initially when we started metformin, since the glucose glycotoxicity was very high, we added sulfonylurea also. As a result, if you will say, in the day 0, glycation is 60% and oxidation is very high. It's almost 50%. Okay. As we start the metformin treatment throughout the study, the glycation improved and oxidation also improved. Oxidative stress came down. But the moment we started adding sulfonylurea to further improve his glycemic status, the way we added sulfonylurea, there is an increase in oxidative stress. Okay. This helped us to understand that metformin has the insulin protection effect. Okay. So metformin always has the insulin protective effect, and sulfonylurea always increases the oxidative stress. Okay, my time is over. But what we showed in my PhD, the current glucose-centric approaches in diabetes are inadequate and incomplete and do not address the need for parallel amelioration of albumin oxidation and oxidative stress. Further therapies of diabetes must decrease or normalize not only hyperglycemia but also albumin oxidation. Albumin oxidation needs independent therapeutic intervention in diabetes. That's why during my postdoc, we are studying the Ayurvedic formulations. We are thinking that the Ayurvedic formulation has the ability to reduce oxidative stress inside the body. Okay? So I will stop here. I already have crossed my sorry matter. So after this, okay. So with all this my data I wanted to show. Okay, so the ultimate conclusion of my PhD was albumin remains the unique model biomolecule. In-depth studies on biological, pathogenetic, and clinical significance of insulin resistance, beta cell dysfunction, and protein molecular modification, and further mechanistic molecular and cellular studies are important, and it is better to the better understanding of the disease pathogenesis and better therapies and prevention strategies are very, very important. Thus, albumin remains a beautiful nature's window to health, disease, and therapy. Yes. And these are Professor Krishna Swami sir, Balram sir, Navkar sir, and Shrikanta sir. I always owe whatever I am today because of this. Thank you so much.
Thank you, ma'am. Thank you for the wonderful session.
Only 1 minute. Any doubts or any questions? In the lab, during lab. We are already late.
No. We would like to request Dr. Sulochana ma'am and Shrikanta sir to felicitate Dr. Madhumati. Okay, coming to the last technical session. Actually, it's not a technical session. It will be a discussion and wrapping up session from Dr. S. Shrikanta sir. Dr. Satyanarayan Shrikanta is a renowned endocrinologist and the founder and the managing trustee of Samatvam Science and Research for Human Welfare Trust, Bangalore. He graduated from Bangalore Medical College in 1971, did his MD in Internal Medicine from All India Institute of Medical Science, Delhi in 1978, and he has specialized his fellowship in endocrinology, diabetes, and metabolism at Duke University Medical Center. At a very young age, he served as the faculty member at Harvard Medical School and clinical investigator at National Institute of Health in the USA. Upon returning India, he established Samatvam Center of Endocrinology, Diabetes Center, and Nana Sanjeevani Medical Center in 1993. He is a recognized fellow at the American College of Endocrinology and a fellow at the Royal College of Physicians, London. His clinical work focuses on the science-spirituality synthesis, providing holistic care, particularly in economically underprivileged patients. Since 1994, he has also served as an honorary senior consultant and faculty at NIMANS, contributing to neuroendocrinology research. He is a research mentor at Indian Institute of Science, collaborating on advanced projects like artificial pancreas and biosensors. Dr. Srikanta has received many numerous awards, including the State Award and Cup for his academic excellence. We welcome you. The stage is open for speakers.
Namaste. When Dr. Sulochana assigns some assignment, I get nervous. I have to do justice. I'm here today because of this miracle angel. And it was she who brought Ayurveda to IASC. She was instrumental. I'm telling you about it. And God brought us together, and she's supposed to retire. We'll not allow her to retire. She'll be with us. Okay. I've been to a diabetes conference about a week ago. Everything is AI, everything is ML. All of you can do PhD thesis in 3 minutes. And every slide, I really felt like nausea and vomiting. I can smell AI. The very dry, flowery things, every slide. It was very sad. And you see the hype. But again, I want to remind you a very important sentence. You come to our clinic. We are very strong in AI last 3.5 years. A professor from Harvard Business School has told, humans will be never replaced by AI. But humans with AI will replace humans without AI. Humans will be never replaced by mobile phones. But humans with mobile phones may be replaced. But one thing AI will definitely not do. It will not improve human happiness. It will not improve human peace. Humanity is not going to become, they're killing each other, every part of the world. India is the best place. So when she told me, I did the trick. I also use UI. You have to be smart. I prepared a PowerPoint talk, everything. Then I felt it very bad. Then I decided through the PowerPoint, I will tell you stories. I decided to tell you stories, and the morning speaker has inspired me. Okay. And this is the time is short, still you are there. I prepare like a high school student. Let me see. Story number 1. I'm 70 years. I turned 70. So I titled my talk as Notes of a Biology Physician Scientist, looking back 50 plus years. So I said, I'm going to meet these young people. Whatever I learned, ups and downs, let me share. So, lesson number 1, destiny. Many things are in life are preordained. That means our destiny is decided. I grew up in Bangalore, in a rural part. I went to medical school on a house which had narrow, and the rent was 21 rupees. That's what my father could pay. Throughout high school, somehow I was addicted to maths. I would get 100 root of 100. If I get 99, I will try for 1 week. And on some May of 1970, one morning, a flood of reporters walked into our house. It's in a lane. Then they told my parents and family, your grandson has topped the SSLC first rank for the whole state of 2 lakh people. And they started interviewing. So in one corner, all of us used to sleep on the floor. They would come and talk to me, the ranker. You know what they asked? Who is your favorite film actress? And all those things like that. And then they asked me, what do you want to become? I was 15. What do I say? 14 and a half. I said, I think I love maths. I want to be a mathematician.
They were interviewing my grandma in one place and my father in another place. My father is a GP. He's a 50 paisa, 1 rupee doctor. Only who could give. If he gives, he will take it. He was one of the oldest. There were 8 doctors in Bangalore. Next morning, all papers had interview pictures of the rank students. And in that all, the headline was, first ranker maths lover, father forcing to become a doctor. That's why I'm here. And then I found out when the reporter asked my dad, what do you want your son want to do? He has told in summer holidays, he comes to my clinic, he makes mixtures, gives tablets. That time it was mixture, sir. So what did I do? I signed up for biology. Otherwise, I wouldn't have been here. Okay. Second, you need a very enlightened mentor. You saw Professor Navakant Bhatt. Madhumati is lucky because she has such enlightened mentors. Go anywhere in the world, you will difficult to find Navakant's Balram, and it's difficult to find our Ayurveda guys. They are making me learn Ayurveda. Now, in India, it's called Acharya Devo Bhava. You should be a caring mentor. All of you have your favorite teachers. I was very lucky. When I went to AIMS in 1978, the head of the department was one of the India's foremost scientists. He's called Professor Manmohan Singh Ahuja Padma Shri. He is a scientist sage, was in AIMS for 40 years. Probably his students are there in endocrine all over the world. Every university is the father of Indian endocrinology and the scientist sage. He was a terror. Nobody wanted to do thesis with him. I went in like the person who did. He inducted me in a nice way and accepted me as a disciple after testing me. And he gave me a topic on type 1 diabetes and autoimmunity, which was very new. Started working, nothing worked. Everybody else took a simple one, blood sugar in diabetes thesis. And I had a co-guide called Malviya. He's the father of Indian immunology. You know, AIMS is the Varanasi. I was lucky enough to be there. And once Professor Malviya came to Bangalore for some reason and he visited my parents, he told, your grandson is a fool. He's doing a difficult topic. Ask him to give it up and take a simple one. I persevered, it worked. Okay. And so you need a good mentor. Something happened. I could publish an article from my thesis in a journal called New England Journal of Medicine. You know, it's the #1 journal from Boston. It got published even before I finished PG. That is over. So your hard work will pay for you. I was in the 3rd year doing an emergency duty in AIMS. And one of my uncles who lives nearby came running with a letter to me. Hey, I was seeing patients. You have got a fellowship in Duke University Medical Center from July 1st. Your stipend is $18,000. He said, I don't know, I never applied for it. Okay. Occasionally there is something called serendipity. By chance happens. And I went and joined there. They don't take Indians. They don't take that to an Indian who has never been to America. In Christmas party, they told me why they took me. I became to know the secret. I set up an assay for islet cell autoantibodies as part of my MD thesis you are doing. I didn't know it will take me there. It came in New England Journal. I never applied to this university. It's one of the top universities. My CV went to some professor, Solman, and he has forwarded to this university. And one of the assistant professors was trying to do research on the same islet cell antibodies, but he had completely failed. And वो सोचा ये इंडियन बंदे को मैं लाने से वो next year मेरा lab में काम करेगा. He said he will be a good and you know why he had failed between you and me. He was a calm show. Okay, and to do this assay, you need fresh pancreas to study that. You need pancreas from heart-beating cadavers. You know, somebody died donation. It's a Herculean task. I was managing it in AIMS. And he was using paraffin fixed sections. You know, histopathology, go to formalin. If you put in formalin, the antigen gets destroyed. So it worked, and that's why I got it. Then the department moved to Harvard. So your hard work will persevere. The next one, I never knew that from this corner lane of Gavipuram, Guttalli. One day God will take me. It's called the Varanasi of Science and Medicine. So here I am 24, 25. Go to this place, Harvard. The first week, good collaborations. You need collaboration and scientific and cross fertilization. 2 plus 2 will become 8. Now, Ayurveda is collaborating with so-called modern medicine, different specialties. That's the place of place. You know, you talked about longitudinal studies, cohort studies. I read a little bit. I have this small assay which I developed in Delhi. I met a old professor at Harvard on a breakfast meeting. His name is Professor Stuart Soldner. He has worked 30 years, 35 years on a longitudinal study. He wanted to find out why people develop diabetes. And predict diabetes before it develops, type 1, type 2. So, sitting in Boston, he used to collect twins and triplets who have one has diabetes, other doesn't have. They are monozygotic twins. One has, the other has. He said, why the other one didn't develop? He was studying them 30 years and some of them developed. He had kept their frozen serum samples 35 years in a deep freezer. And his laboratory technician was same and nuts were same. So I knew that this man is very nice. He's the author of that. I went in at 25 or so. Professor Soldner, I know you are doing. I got this assay from New Delhi, Bangalore. Will you give me small amount of your 35 collection, which I have kept? And he was fine. And within 1 week, his technician gave me 1,000 samples. 2 weeks, I sat and ran. It is all coded. You don't know which year, which patient. He called me to his room. Evening, we were sitting. I used to tell the results. He used to break the code. Half an hour later, he jumped and almost hugged me. He said, you have made my 35 years work. He was looking for a metabolic marker to predict diabetes. We found an immunologic marker. So every youngster who went to develop type 1, I could tell you 5 to 10 years before. So that was a landmark discovery. And within 2 weeks, it was a New England Journal. And believe me, in about a month's time, a picture of me and the group was in Washington News, New York Times, all over America. We diagnosed what is known as pre-type 1 diabetes, and she showed the data on type 2 diabetes. Mine was type 1, it's an autoimmune destruction. A child today comes with ketoacidosis, it is destroying slowly last 5 to 10 years. So now we could predict. The concept is whether you can develop an antigen-specific vaccine. Till now, the dream is coming, every textbook has it. Unfortunately, nobody has succeeded. You can prevent type 1 diabetes in animal models by vaccination, but human has failed. Now, so Lux works, good people works. Now, next one is institutions matter and academic infrastructure matter. Madam got a Center of Excellence in Pari, and their team has built it up so nicely. You know, Pari was in a small building near Lal Bagh. Now they have grown it and it should grow. And you are sitting in a campus. My dream for this country is this campus should produce at least 5 Nobel Prizes in next 10 years. Then, and Modi can make it happen. And morning they were telling, India has the talent, but India has the seed, but you need the soil. Soil is improving, but we need more. So after discovering this type 1, we want to sort of vaccinate. We want to purify the antigens. Because I was at Harvard, I was surrounded with seeds like this. You could walk anywhere. I learned the hybridoma technology, monoclonal antibodies. You have heard it's being used in therapy. And believe me, God gave me the opportunity. I learned the technique and started implementing it. And 2 years later, Polar and Milstein got the Nobel Prize. So here is a boy from India who was exposed to a Nobel because I was there and I had the opportunity. So look for a good institution, good mentors, and many of you, I heard this, they are getting a medical school in IISc, and they are all trying to get integrated medicine. At least 4 of you or 5 of you do PhD in this place. Okay, so that is important. Okay, now, good story, failures. Failures are must. So here, forget about the New York Times, that doesn't matter. Now the passion is to develop a vaccine, purify the antigen and give these children. Sometimes they call you mad also, you can't help it. If you get obsessed with what you are doing. So, these children are making antibodies which destroy. So the dream was take the cells, B lymphocytes. B lymphocytes make antibody, immortalize it. That immortalization of antibody cells is the hybridoma technique. That is the Nobel Prize winning. So I used to take blood, get their B cells separate, fuse it, try to make hybridoma. 1.5 years, every experiment failed. I used to go to all Harvard, everybody would get nothing worked. What do? Deep depression. You say, hell with science. Everything is coming to an end. I had a supervisor, nobody could help me. What do? Alone, single, mommy, daddy, 1,000 miles away. On Sunday, I remember, I decided a different experiment. I decided instead of human monoclonal, to do the mouse monoclonal. Took mice, found some mileage immunized. Between me, after 1.5 years of failure, wouldn't even eat food. You get disgusted. Why am I staying there in that far-off land? Let me run away home. The first experiment worked so beautifully, and I got a bumper harvest. I got about 20-30 monoclonal antibodies. Till now, nobody has got it. And still it is there. And one more thing. My American friend, Andy Powers, met me 5 years ago. They knew the story. He said, Trikanta, don't worry. The experiment we did work. Till now has not worked for anybody. So it doesn't matter. It means biologically there is a problem. So now they make what is known as humanized monoclonal antibodies. They make in the mouse and they change at the genetic level. So failures are part, enjoy it. And now about failures. One of my role models is Abdul Kalam. And you have read his Ignited Minds. About 10 years ago, I changed my title as not as an endocrinologist. My visiting card used to call it gardener. And people were getting surprised. You have heard of Subrata Bakshi, who is building this medical school. Narayan Murthy retired from Infosys. He became chief mentor. Subrata Bakshi, founder of Mindtree, retired. He didn't become chief mentor. He became chief gardener of Mindtree. Mindtree is an IT company. He said, I won't do Upadeksha, I will garden. I like that. I wanted ordinary gardener. Gardener means to irrigate, inspire, and ignite. So, if I can irrigate you, inspire you, ignite you, to see all of you get into high levels is something which all of us enjoy. If a student does better than a teacher, you will be very happy. I got one disciple called Dr. Kavita Muniraj. She is my shishya. But now I sent her abroad, got to train. Every patient I see, she comes and tells me, you have done 10 mistakes. Okay. And I'm so happy. So all patients, if somebody comes, I say, oh, she's my doctor. So you become so proud if your student does better than you. Okay, and failure is a stepping stone in success. Does anybody know what is Abdul Kalam's definition of fail? FAIL, first attempt in learning. Okay, have you heard? He's a great soul. Fail is first attempt in learning. Now, you are all too young. I'm old. I should not bore you, but I will tell you what also happened. It was around 1986. I was there about 6 years. Came home only once to meet my mom, dad, and granny. A lot of problems. Academic problems. In a foreign country, you all should go abroad. You all should work there. But come back home. This country is the best country anywhere. You will never find it. And it is becoming better everywhere. Nothing but Sanatana Dharma. See the Gaza, see the Middle East. Now, Iran, that one idiot wants to do. What do you do about it? Okay? You will. By the way, all my family members are stuck in America miserably. All my brothers, sisters, they all tell me I'm the only lucky one. Their heart is hanging here, but their all bodies are hanging there. Okay. And what do you do about it? My sister is a doctor, endocrinologist, 2 brothers. My dad has 15 great grandchildren. Last is Keshava, all born in America. They don't know anything. Okay, forget about it. So, when you are actually you are many times a beggar in a foreign country. You are insignificant. And there in the most powerful place, so-called Harvard, nobody cares for you. You are left alone, purposeless. Though some things are going, purposeless, directionless. There also you have all these institutional politics. You need to lead somebody to grow. I was not part of it. So I didn't know what to do, got confused. Another one point. There were no inspirational mentors. I didn't get an Avakan. I didn't get a Padmanabhan Balram. I didn't have collaborators like Shubh and our Sulochana, etc. You feel lost in life, particularly the 20s. Then there was one more problem. Why do you want to do science? Morning, doctor told, there is something bigger purpose. The science I saw, majority of science in the best place was for self-aggrandizement, not for human and societal good. Science I saw, majority was for self-aggrandizement, not for human and societal good. One big professor was there, he had put a board, Nobel or bust. That means his goal in life is Nobel Prize. Helping patients. That disillusioned me. What do? I decided to quit medical school, applied for 10 universities for PhD, divinity and theology. At that time, an associate professor, you should enjoy what you want to do. I never found an atmosphere like this. There are good people, better people, but I was not lucky. And I had to write my letter now. Immediate doctor is trying to scientist becoming, etc. All publications. I was doing immunochemistry, molecular cloning, etc. I said I want to do PhD in divinity, and because I want answers to two questions. You are all too young. Sometime in your life you will ask this. My PhD protocol, what I wanted was, what is the meaning of life and what is the purpose of life? I said, I'm not understanding it. I'm around it. So I want to do PhD on this. The Harvard Divinity School had a professor. Do you know what was it? Last 25 years he was doing? This is an American. The topic of his thesis 30 years was Sri Ramanuja's Bhakti. Sri Ramanuja's Bhakti, this professor was studying for 25 to 30 years. Finally, that application was not moving, but I found answers somewhere else. It was the Sri Ramakrishna Mission of Boston and the Vedanta Society of Boston. We knew about Ramakrishna Mission as children. We were told about Vivekananda, but never pursued it. Arise, awake, stop not till the goal is reached. All that Uttishta Jagrata, they were taught to us, but in high school, but it didn't go inside. So I did, and I found all my answers there. 1986, January to September, the Swamijis cleaned my brain. They taught me Vedanta, they taught me Bible, they taught me Quran, they taught Buddha. They would not teach isms and ditties. They only will teach noble souls. They were very learned. Physicists, scientists, engineers, who had become monks of the Ramakrishna order. You know, Swami Vivekananda has told about the purpose of life, explanation of Vedanta. That they are too young. When you get to Buddha, you can think about it. Okay. Our purpose is to grow from animal to human and try to walk towards divine. And Swami Sarvagatananda taught us very simply, give more than you take. That's all. Give more than you take. My mama was always telling us that. And I met the senior most Swamiji of the Sri Ramakrishna Mission alive. He was the direct disciple of Sharda Devi. 40 years he went to America, never came. Physicist, tennis player, Swami Asheshanandaji Maharaj. You listen to his lecture, my God, he was in 90s, so powerful. He told all of us, don't be a creeper, be a tree. He would teach us all of that. Don't be a creeper, be a tree. See, that was the 9 months where I needed some direction. That was my PhD. They silently sent me back to India. I walked out without a job, without anything, landed in New Delhi one fine day. Again, I'll tell you, I remember, I walked out on New Delhi airport, went back to AIMS. No room, nothing. Went to the same North Indian mess, gave my bag and slept somewhere. I 3 months to get some place to sleep. I went back to my mentor, Professor Ahuja. But what invited, when as soon as I came to India, in the outside Delhi airport, there was a big sign. It destroyed me. It was advertisement for a woman-only cigarette called MS. This was not the India I left 7 years ago. You mean I come here for something, I see negative developments in this cigarette was only for women. Big advertisement. MS was the name. Believe me or not. What do? I come here, forget. We have to move along. I thought India would have, but okay, forget. Now, last point. You go to this famous Massachusetts Institute of Technology, Boston, Cambridge, from the river. Do you know in the opening hall, you will find an inscription on the wall. Science without religion is lame. Religion without science is blind. Do you know who told it? Dr. Albert Einstein. Science without religion is lame. Religion without science is blind. Any one of you have heard of a physician scientist called Yella Pragada Subbarao? If you have not read, please Google tomorrow or day after. He should have received at least 2 Nobel Prizes. Chennai, Andhra Pradesh, went to US, never came back. Married, left his wife, never came to meet her. Great soul. Physician scientist. He made so many discoveries. His folic acid is his. His ATP creatinine reaction is his. But Harvard professor actually published it. It's a Subbarao reaction. And the first cancer drug is his. It's chemotherapy, methotrexate. Not everybody accepted. He was denied Nobel Prize because he was black and forget about it. His student got the Nobel Prize, Sidney Farber, for methotrexate. He died there only, donated everything to church and died. There is an inscription on his bust. Science can only prolong life, religion deepens it. But one thing, whether it's Einstein or Subbarao, remove religion, put spirituality. Okay, religion is not to be talked about. Last point. Okay, I came back, life is good. I'm meeting so many people. The last 30 years have been very beautiful. And a lot of good people all over the world come and help us. We need to be grateful to our parents, Matrudev, Pitrudev, Acharya Devobhava, everybody. Dr. Gankapa taught us, Shishu Devobhava. You need to treat all your patients as God. There's a French word called raison d'etre. Raison d'etre means reason for our existence. Reason for our existence as doctors are our patients. They are our living God. We need to take care. You are all doing it. And by the way, next 10 janams, I want to be a doctor only, never a mathematician. Okay. And one Thomas Louis is a famous writer, American doctor scientist. He has told computers, they are dead, they can't emote, react. Humans you enjoy. Once you get addicted to medicine, you can't get out of it. Last, let me close with I took a long time, very simple story. Here I am staying behind the hospital in Boston, in an old apartment, and several people, there was a janitor and a plumber who would fix cleaner. He knew this doctor goes every day, comes. One day he stopped me. He said, hey doc, I have $2 in my pocket. Suppose I give to somebody, I lose those $2. He's an illiterate janitor. Now, can you tell me which are the 2 things in life which you give to others, you don't lose? He asked me a question, that illiterate person. I said, man, you tell me. He said, Doc, it is love and knowledge. So we are coming here to spread love and knowledge. This guys never spoken. God bless you. Thank you. Thank you all. And we have a small center in JP Nagar. You are most welcome. We run perhaps the world's first integrated endocrinology diabetes clinic because of these 2 people. And our endocrine field. No, I got my Ayurveda, two doctors, very bright like you, and Preeti, the endocrinologist. They sit next to each other. Rooms all connected. Patient goes and sees. A lot of wonderful things are going on. Somebody said that the Ayurveda should get minimum 5 Nobel Prizes. By the way, 2017 Nobel Prize went to Chinese medicine. Do you know that? Herbal medicine. Ivermectin. Why you people cannot get it? Please get it.
Yes, sir. Thank you so much for inspiring all our young souls. I would like to request Dr. Subhashri ma'am and Sulochana ma'am to share the token of love with Dr. Shrikanta sir. I will also request Dr. Rodmani sir and Giri sir to join them.
Do you know? Two Ayurveda doctors said about 12 allopathy doctors. Well, I honestly tell you not to take. Their handwriting are the best, their workup is the best. They are the most meticulous. Very much no handwriting. Madhumati, come along. Come. Hey, you should come. Who coordinates all our body. You are welcome to visit our center anytime you can start seeing patients. And after you graduate, you can come and do projects.
Thank you all for being patient with us throughout the day. Now we will have a group photo in front of this building. After that, we will have the lab visit with ma'am. I would request everyone to come out of the room and gather in the steps. Yeah. Also, the feedback form has been sent to you through WhatsApp. Your respective coordinators will forward it to you. Please fill your feedback form. It would really help us to improve ourselves in our coming sessions. Thank you. Yes, Harry Bengaluru, you can also put your review on the Google review you can add. Please rate us. You can share your experiences. You can also visit our center. I hope some of you have come for our institute for visit, and you are all welcome to visit it again and also put review on